New materials, intelligent manufacturing systems, smart mobility, biomedicine and medical technology. These are the main fields in which we pursue research, development and innovation in the Pilsen region. Create your future with us. Innovate with us. Our region has a history of innovation. Important trade routes have always led through here. The first book was printed here. The first electric lamp was lit. We've seen dynamic developments in transport and new fields of medicine. Two of the world's leading brands, Škoda and Pilsner Urquell, were created here. We are successfully continuing this tradition. We are a region with traditionally strong industrial players, innovative companies, and major university institutions and successful research centres. But we're not just an industrial region. You can spend your free time wandering through the countryside or visiting historical and industrial monuments. You can be active or relax with great food and great beer. There's something for everyone. Here in the Pilsen region, we're involved in materials engineering. Research into metallic materials, 3D printed machine tools, special steels, the research and application of thermal spraying, and new technologies for the forming and heat treatment of metals for mechanical engineering and the automotive and energy industries. For example, if you ever come across a smart window which controls the amount of thermal solar radiation passing through depending on temperature thanks to a special coating, this patent originates from research at our university. Manufacturing, power plants and industry in the Czech Republic and abroad use intelligent control systems designed by engineers from innovative companies from the Pilsen region. The university's Research Technology Centre is developing completely new applications for contactless thermal imaging measurement, and not only for industry. Sophisticated computers that are built into medical devices are saving people's lives, and they're also being used in industry, transport and aviation. Smooth running. Let's take a look at another rapidly developing field, smart mobility. But we're not talking about just developing new electric drive systems. This is about a whole range of technological innovations for the operation and management of urban traffic, wireless charging, autonomous systems testing, and transmission development. One leading field we're dedicated to is biomedicine. This focuses on research and development in the fields of organ replacement and regeneration. This includes research into the prevention of viral infections after kidney transplantation, as well as research into antibiotic resistance. Specialist software is helping to diagnose and treat liver cancer as sensitively as possible. Software and diagnostics are also helping to prevent transport, medical, and sports injuries. Create your future with us. Utilize the potential of the Pilsen region. In practice, in research, at the university. There will always be innovation. Let's succeed together in
Esteemed participants, with great pleasure, we warmly welcome each of you here on this gathering of minds on 7th International Conference of Design, Simulation, Manufacturing, the Innovation Exchange. It's fascinating to see you all here, representing various fields in manufacturing, materials, mechanical engineering. This event is more than just meeting. It's a chance for us to get together, to share our ideas, new maybe opinions, and explore opportunities for collaboration. As it happens, we are already a big scientific family, and each year our big family enlarge with each our meeting. So newcomers, be careful, DSMIE is addictive. Together we can do more for science, technology, engineering, and education. And that's precisely what we are here to do. Thank you for being part of this journey. And now it's my great honor to introduce our distinguished leader who has shown an exceptional vision in guiding our efforts to make this event successful. Professor Vitaly Ivanov, I invite you.
Dear participants, dear colleagues, dear friends, good morning. Good morning to all who are now in this room. Good morning to everyone who online now and see us through the digital technologies. It's my great pleasure to welcome you here in Pilsen. The weather is pretty good, thanks to our local organizing team. And let me start a little bit about the conference. First of all, I would like to say a few words about the idea of this conference. It has been started in 2018 in Sumy City, Ukraine, and it was the opportunity to gather together participants, researchers from different fields like design, simulation, manufacturing, and combining all of them in one place, in our opinion, is progress and can be make more some benefits. We are traveling across the Ukraine from west to east, from Lutsk, Kharkiv, Lviv, Poznan. It was a challenge for us because 2022 was really terrific, and I am grateful to our partners from Poznan University of Technology who supported us that time. Next year we spent conference in Slovak Republic due to close cooperation with Technical University of Košice. And now thank you very much to University of West Bohemia who hosted us here. We are not stopping. We have already defined the further conference venue. It will be announced very soon. It's proud for us that DSMIE conference series is a Ukrainian brand recognized internationally. And this year, as I mentioned, it is organized by University of West Bohemia, International Association for Technological Development and Innovations, and Sumy State University. We appreciate the support of our partners and sponsors who supported during our timeline of the conference. At the same time, we are delighted to say thank you very much to the governor of the Pilsen region, Mr. Rudolf Spotak, for his acceptance, support, sponsorship, and personal presence here. Thank you. Also, we appreciate the support of our partners who supported us in different ways. And thank you very much to Daikin Industries company for hosting us here during this conference dates. And also, industry tour is scheduled for this Japanese company. Our conference implies several ideas, and we try to implement teamwork, ideas exchange, and also pay attention on the quality of the research. For us, it's important, and I think for you also. Some numbers you can see now on the slide, and it shows the scale of the conference during this edition and the conference series as a whole. We cover design, simulation, and manufacturing issues in 3 areas. So, manufacturing engineering, mechanical engineering, materials engineering. This year structure is the following. We will have keynote sessions. We will have the session Business to Science, where our speakers will share their experience of cooperation with industry, and also 8 thematic sessions. I appreciate the acceptance of our session chairs. All of them are here. And during these 2 days, you will have the chance to interact with them, make partnership, and learn more about these issues. During our conference, we have a wide range of countries and speakers. At this moment, we have already learned 31 case studies from different countries, from our speakers. And it's my great pleasure that 6 keynote speakers are now in this room. It's great, I think. Many thanks to our keynote speakers, Professor Arkadiusz Gola, Professor Foivos Psarommatis from Norway, Professor Francisco Silva from Porto Polytechnic, Professor Andre Batako from United Kingdom, and one more speaker will join us afternoon, Professor Xu from China. Also, thank you very much to our invited speakers who will share their experience, and our speakers from Germany and Czech Republic, Miroslav, Zetek, Tomáš, Cholinský, Gerhard, Meindl, Dmitro Adamenko, and Andy Gradle. They are working and will come. Also, for the first time, we organized the workshop during the conference, and this is a special edition with a partnership with NAVA, Polish Agency for Academic Exchange, who was one of the contributors for this event. And I am happy to introduce our invited lecturers, Dr. Bogdan Haidabrus from Latvia, and Professor Katarzyna Antosz from Poland. We have already published several books, all of them indexed by Scopus, some of them indexed by Web of Science. This year's edition books are ready for publishing. I believe you received the proofs. Yes? Okay, thank you for confirmation. The first volume will be published next week. The second volume will be published a little bit later, but everything was agreed according to the contract. This edition includes 10 chapters, 2 volumes, 83 accepted papers, and now you can see different keywords associated with these publications in these books. And many thanks to my co-editors in this journey, and I appreciate Professor Ivan Pavlenko, Dr. Justina Trojanovska, Professor Erwin Rauch, Professor Jan Pittel. Special thanks to Dr. Milan Edl, Professor José Machado from Portugal, and Professor Xu from China. He will be. Don't remember that your research results can be published also as extended versions or a new one in our partner journals. Now you can see the editions that provide cooperation with us and kind support. Also, we have launched 2 special issues. You can also contribute to them, and the time is specified. Thank you very much to DSMIE team. It is impossible to organize a conference by oneself. And in my opinion, that the team of like-minded people who joined with a single aim is a very powerful tool. Thank you very much to my team, and I appreciate to collaborate with all of you during this time. Thank you. That's all for now. Thank you.
Thank you very much. We are privileged to have an estimated person, Professor Milan Edl, who played an essential role. So I invite you, Professor Milan Edl, co-organizer of conference, professor of West Bohemian University.
Thank you. Good morning for all. Dobrý den, dobrý deň, buenos dias, buongiorno, dzień dobry. Let me welcome you on behalf of the conference organizers. That organizers are Sumy State University, University of West Bohemia, and International Association for Technological Development and Innovation. And here at a beautiful building and space of Daikin, thank you very much for your support. I must highlight that event is held under patronate of Governor of Pilsen region, Mr. Rudolf Špoták, and with support Rector of University of West Bohemia in Pilsen. Thank you very much, gentlemen, for your support. And I must remember our first joint meeting in April 2017 in Kiev, where I met with Vitaly Ivanov first time and with Dean Alexander Gusak, together with Mr. Jans de Boer, where is here. Thank you for this meeting. I think this is a very important point for future, for maybe today meeting. This conference, I am happy that this conference, International Conference on Design, Simulation, Manufacturing, the Innovation Exchange is in this place. Thank you very much for energy, vitality, and efforts of Vitaly and his team. I am happy that this conference is also part of our joint efforts. Today's conference will be attended by 75 participants from 16 countries. I welcome participants from Belgium, Czech Republic, Germany, China, Italy, Latvia, Poland, Norway, Portugal, Romania, Slovakia, Sri Lanka, Thailand, Ukraine, United Kingdom, and Uzbekistan. As I often say, every event should have two dimensions. One is professional expert one. I have no doubt about that, and also social one, and I hope it will succeed. Thank you to both dimensions, we are able to create new partnership, friendships, and cooperation for the future. Simply, welcome in Pilsen.
And we are deeply honored to have with us today Governor of Pilsen region, Mr. Rudolf Spotak. I invite you to a few welcome messages.
Dobré ráno, good morning, ladies and gentlemen. So I will be so shortly because I mean that the best political speech is the short speech. So welcome in Pilsen region, welcome in Plzen to this conference. You know that the Plzen is the capital city of the beer on the world. And I hope that in the future we will be, with the cooperation with Bohemia University, we will be the capital city of innovation in Czech Republic. Is our topic for the next year, and I think that this conference is one of the very good points for this and for our work for innovation, not only in our region, in the cooperation with the other region, I think in Germany and Italy and Portugal and so on. So Professor Ivanov said that we sponsored this conference is sponsored by the Pilsen region, not myself, for all. That thank you, ladies and gentlemen, that you coming here in Plzen and Pilsen region and have a nice conference. Thank you.
And I want also to invite the person whose leadership play a crucial role in making this conference in Pilsen. Mr. Miroslav Lavichka, rector of university. Professor, I'm sorry, Professor Miroslav Lavichka. Please, take your time.
Good morning, ladies and gentlemen, dear colleagues. It's my great pleasure to welcome you at this opening ceremony of this conference. And it's a great honor for me to see and greet so many distinguished researchers, engineers, scientists, experts in their fields. Our university this year celebrates 75th anniversary of the foundation of our old technical faculties. It means it's 75th anniversary of the foundation of the technical higher education in Pilsen. So I would like to thank the organizers for bringing this conference to Pilsen exactly in this year, because it's a great gift to our university. Thank you very much that this is exactly the right year for organizing this conference in Pilsen. In the next few days, you will have opportunity to attend interesting lectures, to interesting contribution talks. You will have opportunity to discuss several topics. Maybe you will solve many open problems in your fields, but mainly it's also opportunity to start some collaboration, because conferences are mainly important, or one of the main things of conferences is that it's opportunity to networking. It was already said that each conference has a scientific part, which will be surely successful, and also social part. So I believe that you will enjoy also the social part. You will enjoy Pilsen and its sites, And you will also enjoy the Pilsner brewery, as it was already many times said, because to be in Pilsen and not to be in Pilsner brewery, it's, how to say it, it's incomplete. So please enjoy Pilsen with all sides and with all opportunities. And I believe that you will return to Pilsen in some different opportunity. And I wish you successful conference, inspiring conference, and I wish you also pleasant stay in Pilsen. Thank you very much.
And now I invite Professor Vladimir Duchek, Dean of Manufacturing Engineering Faculty, Mechanical Engineering. I'm sorry.
Good morning, ladies and gentlemen. It is my great honor to welcome you to the 7th International Conference, Design, Simulation, Manufacturing, the Innovation Exchange 2024. I welcome you to our university and to Pilsen. Your attendance is greatly appreciated and earns the conference an international prestige. The Faculty of Mechanical Engineering is an important institution in education and science. A majority of private businesses in the region benefit from long-term partnership with our faculty, thanks to which the faculty represents important accelerator of economic growth in the region. Pilsen and its surroundings are significant industrial agglomeration in European context. Today's conference and your presence enable mutual sharing of the latest findings and therefore improve the competitiveness of our region. My special thanks go to Daikin Company, namely Mr. Jan Voch, Control Department Manager, for supporting of conference. I can see from conference program that many contributions are focused on energy and environmental technologies. This fact strengthens the importance of the conference because this year the Faculty of Mechanical Engineering is preparing a new study program in environmental engineering, massively financed by European funds. I trust you were satisfied with the tour of laboratories of our Regional Technological Institute yesterday. Our laboratories offer great opportunity to establish new international partnership between various research teams. I welcome you once more, and I wish you a successful conference and pleasant stay in Pilsen beyond the official program. Thank you for your kind attention.
Dear Professor, this small sign is so remember about this conference and thank you very much for your support.
Thank you. Thank you very much.
And we also honored the support of industry, and I invite from Daikin Industries, Mr. Peter Nachman.
Good morning, dear ladies and gentlemen, Mr. Governor, Mr. Rector. I'd like to welcome in our factory in regarding good relations with Western Bohemia University. Thanks for your visit. I believe that you will be satisfied with this technical conference, and for this purpose we prepared at the end for you special factory tour where you can see one of the best laboratories in the Europe. Thanks again and good luck.
Ještě tak? se neumíme fotit.
Ne, my jsme takový větší. Dobrý, jo?
Tak jo, ještě jednou. Díky.
And I already told you that DSMIE is addictive. So I guess I may invite most addictive person, Professor Olaf Ciszak, who supported us since our first conference, since 2018. Due to the prominent support, DSMIE 2022 was relocated in Poznan University of Technology because of war. So we are really gratitude. So please, I invite you to welcome and message.
Okay. Thank you, Leah. Hello for everyone. Dear Mr. Governor, Mr. Rectors, thank you for your very warm words. That's true. That's very important for the conference to meet together, to prepare new networks, to work together, probably in the future to another edition of this conference, what is very important. From my point of view, it's very important to connect with the industry. Like the main words of your conference, our conference is we can do more for the technologies, for the innovations, for the education, etc. That's very important for us. But as a dean, I have one very important task. As you remember, at the beginning of the October, our friends from Summer State University celebrate the 75 years old from its foundation. Now it's a 75 and a half old university. In my honor, I would like to wish you, of course, all the best, but a lot of new ideas, a lot of new inventions, great stuff, academic stuff, and new conception how to work with the industry. As you know, we have a very hard time, especially you, but it looks we can do online and other possibilities to work together to prepare new conception to new innovation. And I would like to invite Dean Professor Ciszak, my friend from the Summer State University, of course, Professor Ivanov, please. Yes, and my friend Ivan Pavlenko probably is on the hall. Yes, Ivan, please come here. And my dean, Justyna Czolowska, everyone know her. Because we can't attempt at this time on the Summer State University, we can't remain online, but today is a good occasion. We prepare a gift for our friendship at the first, with the collaboration between our universities. On your hand, Dean, please. The special agenda, special list for you. Yes, and of course, photo. Come to us. Maybe. Okay, we can start the Keynote session. No, it's work for you. Thank you once more for our collaboration.
Thank you very much, Professor Ciszak, for these words. But now I want also to stop at important information and announcements. So I want to to say that the conference will be in hybrid mode, and you can join us via YouTube. You see a QR code. You may scan it. It's YouTube channel of International Association for Technological Development and Innovations, IATDI. Second, on the badge, you also see, you can see my badge here, but on your badge, you will see QR code also. Here, you will see, here is information about your name, surname, affiliation, email, and phone number. So you may share that information to facilitate the change of your contacts. But please remember that it's your responsibility to share or to not to share. So this business card will already formed in your phone. Just click OK and you may check. So, but in against the side of the badge, you will see general. You will see also QR code is a link to general agenda. But detailed agenda you may read on the doors and on the booklets at the tables in hall. I also draw your attention that we have parallel sessions. So this hall will be divided in two separated halls, and I just ask you strong to strict time. Yes, and also session chair will control the time. It made because some person may be interested in another presentation in another hall, and we would like you to visit that presentation, what we want to see. So, according to the conference program, coffee breaks and lunch will held here in this building. And I also ask you at 1 p.m. Please together on official photo. At 4 p.m. the direct bus transfer. 4 p.m. Direct bus transfer is organized to visit Pilsner Ulkvar brewery tour. Yes, and there we will have also get together party. Pilsner Ulkvar holds a significant place in history of brewery. As you know, that the first pale lagers was brewed in 1842 in this place. So, and all secrets and all maybe interesting moments about creation of this beer you may see in this tour. We also understand that it's hard to concentrate on scientific talks after heavy head of the memories after brewing tour. So we decided that we will start our second day of conference at 10 o'clock in the morning. So 6th June will be from 10 o'clock in the morning. And at 5 p.m. We also invite you at awards and closing ceremony. I want to hint that the International Association for Technological Development and Innovations had established an award, and 3 awards you can see here. 3 best presentations will be selected and awarded. And also we will summarize the results, and we also will announce the venue of conference DSMIE 2024. And one more award will be granted to IATDI member who made a significant contribution. Also, we don't say goodbye, and this day, tomorrow, we will not say goodbye after awards and closing ceremony, and we wait you at 19:30 for the gala dinner in CZECH restaurant, address you see here. We emphasize that you can plan your transfer to venue on your own. On the 7th of June, we invite you in industry tour to the Daikin company. And also we will visit Karlstein Castle. It will be with one day, with one bus. And please note that we are planning to return at 7 p.m. So if you have maybe trams, so please notify it. But we may propose for you at 5:30 p.m. We may take you to Karlstein railway station, and from that railway station there are trams every 30 minutes to Prague. So you may plan your visit to Prague. Yes, and also Karlstein Castle, that castle what we plan to visit. Yes, and also we're thinking about young generation of engineers, and I want also to say that we launched this year the second summer school, DSMIE Summer School 2024, and the students and PhD students watching our translation via YouTube channel, so say hello for them. Yes. So we wish you an amazing time at the DSMIE conference. And now I declare the opening of Keynote session, and I again invite Professor Olaf Ciszak. Polytechnika Poznańska, Poznań University of Technology. And I want also notify that Olaf Ciszak was first keynote speaker of conference. Yes. So please.
Thank you, Julia. Thank you for the invitation. Hello once more for everyone, dear colleagues, dear friends. I think we should start work on our researchers area. Our first keynote session will be Professor Arkadiusz Gola, my friend from the Poznań Technical University, who Poznań, sorry. I would like you will be from Poznań, from the Lublin, of course, University of Technology, who present the speech on the subject challenges in manufacturing system designing in the aspect of Industry 4 and Industry 5 assessment in the like in the future. Of course, please come to us, Arkadiusz. The stage is yours. Of course, the presenter pointer for you, the microphone, the stage, you're there. Of course, the projector, and please start.
Thank you very much, Mr. Chairman. Hello to everyone. As Olaf said, my name is Arkadiusz Gola. I'm from Lublin University of Technology in Poland, and I work at the Faculty of Mechanical Engineering in the Department of Production, Computerization and Robotization. But for the 12 years, I was working at the Faculty of Management, and therefore I will also say something about not only designing, but also management of or in manufacturing systems of, let's say, future. Where should I? Oh, okay. Okay, sorry. So maybe I will start from a short history because me and I know that the next speaker will talk about Industry 4.0, Industry 5.0. This is hot topic now, but a little bit history. As you probably know, the first three revolutions were connected with steam energy. It was the first industrial revolution dated around 1765. The second industrial revolution was connected with electricity and implementing electricity into the industry. The third industrial revolution was connected with automation control, also in industry, and therefore it's called third industrial revolution. But when talking about the, talking about manufacturing systems, it is very, let's say, interesting that for the first 19 ages, the only way of manufacturing was craft manufacturing. So the products were produced by highly skilled workers. These products were very unique, but this type of manufacturing, let's say, was very, very expensive. Everything has changed at the beginning of the 20th century, thanks to the Henry Ford, and he implemented the electricity into the factory, and he's famous from the electricity moved assembly line, and of course because of the famous car Model T. It was very interesting because thanks to this assembly line, it was possible to produce more than 19 million vehicles during the 16 years. So for that time, it was amazing. It means, of course, that over 1 million cars were being manufactured each year. But what was also important in the aspect of the history, that this type of manufacturing was totally unflexible, and Henry Ford said that you can have any color of Model T car as long as it's black. So this type of production was maybe not very, but was cheap. But on the other hand, was completely unflexible. But people wanted to have not maybe unique, but different products. Yeah. So the third stage, when talking about manufacturing systems, manufacturing systems development stages, was flexible manufacturing systems, and this type of manufacturing systems. The definition says that it was a group of numerically controlled machine tools interconnected by a central control systems. The various machining cells were interconnected via loading and unloading stations by an automated transport systems. But what is interesting, that this idea of manufacturing systems was stopped suddenly in the 1980s. Of course, some of you can say that I don't agree, because we are still talking about flexible manufacturing systems, but it's another, let's say, type of meaning of flexibility. I will say something maybe later. What was the reason of that? Because the idea of flexible manufacturing systems was to produce in a maximum flexible way as possible. So to produce many different products on the same line, and this type of production was very flexible, but also was very, very expensive. So at the beginning of this century, it was difficult to say what type of manufacturing systems is the most desired one. But let's back to the history. So when we try to compare the industrial revolutions with the stages in manufacturing systems design, we can see that it's a strict connection between second industrial revolution and this famous manufacturing system of Henry Ford. The third industrial revolution, flexible manufacturing systems. But now we have 4 and 5 industrial revolution. In the history, and now, always, the designing of manufacturing systems, is, let's say, compromise between market requirements and existing technology. Nowadays, when talking about market requirements, we are talking about 2 challenges, desires, so mass customization and mass personalization. What is the difference? When talking about mass customization, as you can see in the definition, that the client can place an order and adjust it to his/her needs by means of limited selections from the list. While mass personalization means the product is directly designed and manufacturing taking into account individual needs, fancies, and desires. So the best example of the mass customization is automotive industry. Because when we are buying a car, we can select color, engine, different type of equipment, but we have a list of colors, list of engines, and we can adapt the product to our needs, but we have some limitations. It was, let's say, a compromise between flexibility and costs. But nowadays, we are talking about mass personalization. We want to have unit products. An example, for example, furniture in kitchen, yeah, and we still need to buy as cheap as possible. So let's say the challenge is still growing. So let's go to the Industry 4.0. Probably you know it very well, but just to remind, the idea of Industry 4.0 was announced and in 2011 in Hanover during the Hanover Fair, and it means that Industry 4.0 means that it's an intelligent combination of machines and industrial processes based on new information and communication technologies, and with different technologies such digital twins and so on and so on and so on. So the question is, how the manufacturing system should look like in the era of Industry 4.0. When we are talking about manufacturing paradigms of Industry 4.0, we can distinguish 3 such elements, like the change in manufacturing, characterized by the introduction of physically distributed but digitally integrated systems, new business models, the change in the product's architecture itself. And when talking about manufacturing systems, I think that the most promising idea is the idea of reconfigurable manufacturing systems, This type of manufacturing systems was introduced by the Professor Joram Koren at the beginning of the 21st century. And nowadays, we have a lot of research in this area. This type of manufacturing systems means that we design manufacturing system with capacity and functionality exactly needed to the present needs, but the system is characterized by modularity and flexibility and scalability. That means that it can be easily changed to another requirements and market requirements. So this type of system is. I will go into details. I won't go in details now, but it's characterized by 6 such elements as customization, convertibility, scalability, modularity, integrability, and diagnosability. So, as I mentioned before, it can be easily adapted to current needs. I can also mention, and the idea is not more flexibility that needed in each time. I can also mention that was also a quite good idea of focused flexibility manufacturing systems introduced by Professor Tullio from Milano. And that idea was to, let's say, try to predict the necessary flexibility of manufacturing systems and to design the flexible to manufacturing system for specific time, as we have now, for example, with some kitchen or toilet equipment, like washing machines or something like this. But that idea has been stopped because it's really difficult to predict the changes in techniques and market requirements now. So and nowadays, let's say the most challenging idea seems to be this type of manufacturing systems, but also you can say that it's not true. I saw many papers with intelligent manufacturing systems, smart manufacturing systems, and other types of manufacturing systems, and it's also true. What is the reason? Because this type of systems is focused on the structure, let's say the designing of structure of system. When we are talking about intelligence, smartness, there are also another aspects. In fact, it means that each reconfigurable system can be smart or intelligent, but not each intelligent systems can be reconfigurable in its structure. Here you can see the typical structure of such reconfigurable manufacturing systems. I won't describe it. It can be easily found in literature. And Industry 5.0. In 2021, European Commission issued a document, Industry 5.0 towards a sustainable, human-centered and resilient European industry, and called it 5.0. And the first question is it a real fifth revolution? We have a lot of discussion. Some people says that it's 4.1, that is not a real revolution, that is something like government, let's say, papers, not real revolution, but let's say not try to discuss about it, but some let's say facts that are in this document. When talking about this industry revolution, we can read in this paper that industry is a human-centered design solution where the human and cobots work together with human information sources to enable personalized autonomous production through the enterprise's social networks. So let's say that the main idea of this document was to emphasize the role of human in manufacturing, because Industry 4.0 was strictly focused on the system, on the digitalization, on the machine tools, communication between machine tools, and so on and so on and so on. But we can say that this idea forgot about the people. And this document tried to emphasize the role of human in the manufacturing and manufacturing systems. And the idea of Industry 5.0 is based on 3 pillars. So people centricity, sustainability, and resilience. And we can ask further, what are the challenges of designing a manufacturing system in the aspect of Industry 5.0 assumptions? And together with my colleagues, we gathered different analyzing literature. We tried to gather different, let's say, challenges, barriers connected with implementing the ideas of Industry 5.0 revolution. But to be honest, because of the topic of my work, we were focused on the robotics and in the aspect of Industry 5.0 cobots. That means cooperative robots that that will cooperate with human in manufacturing plants. Of course, I want to describe all these challenges we gathered, but in general we grouped it into four groups. The first is social challenges. And some of them, not some of them, you can see technology, trust and acceptance, changing the dynamics of the team, lifelong learning, skilled workers, human resources management. And in our opinion, it is really, really important, these social challenges, because when we are thinking about human-robot cooperation, it's not easy. Maybe I will give another example about let's say influence of technology on society and some social conditions. So I have a question. For example, how do you think, when I was a child, who was the wiser in the family? The wiser person? Or grandfather even, yeah? Probably father, grandfather, yeah? I remember that I have in my mind one let's say picture when I was a child, and my grandfather was sitting and told us, oh, some years ago I was in Warsaw, the capital of Poland, and in the center is a palace of science and culture. It is such high building, higher than the clouds, and we were sitting and, wow, that really? wow, that it was someone, yeah? So the second question, who was the wisest person 3 years ago in the family? Uncle Google, yeah? And probably 3 years ago, when my grandpa said something like this, I will check in computer and I will say directly, Grandpa, the height of the palace is 237 meters, while the level of clouds is between 1,000 and 1,500. So you are a liar, yeah. So it's everything changed. So the third question: who is the wisest, let's say, person now in our families? ChatGPT, yeah. So the technology is moving very, very fast, and it will have high impact on our, let's say, relation and the ways of functioning. But we will discuss a bit about it later also. The second group are the technical challenges, and here we have technical form of cobots, human-centered AI and personalized AI, transparency, explainability, performance measurement, production systems research. Access to large amounts of data in real time, data analytics, scalability, cobot maintenance, data quality, logistics support. Of course, all these elements of these challenges you can find in my papers. The third group is safety challenges, so authentication, integrity, access control, audit, privacy, human-robot collaboration in the factory, why it is important and why it is treated like a challenge, because now we also have cobots in companies. But we have to know that nowadays cooperation people with cobots mean that people and robots work in the same area, because we have industrial robots with a very high speed of movements, and they have to have barriers. But we have also cobots, cooperative robots, without these barriers, but it doesn't mean that they are working, let's say, hand with people. They are working together with people, but moving not hand in hand. But now we have to think about cobots like robots equipped with artificial intelligence that will learn from people by voice communicates. And I think it's a question of 5 years. We have a lot of research in this area, and probably in few years we will see cobots that are working together with people. We will have another challenges connected with safety, of course with these social challenges too. And the second and the fourth group of challenges are the legal and ethical challenges. And we distinguished here regulatory compliance and sustainable development. So as I mentioned, now when we are talking about cobots and collaborative robots, we have to think about such type of cooperation where robots are equipped with artificial intelligence and work together with people. So at the end, the last questions. How do you think, which of these factors are the most important ones? Because we are thinking also about it. The answer is always, it depends. Yeah? But for example, for more of us, the safety, because safety first, maybe technical, because more of us is working in artificial intelligence, in designing and manufacturing. But it is also true. But I mentioned that I worked also in management faculty, and maybe why I'm talking about, because I think that the idea of the keynote speaker of the keynote presentation is to give some ideas for future research. And in my opinion, the most challenging one is these social challenges. Because as I mentioned a bit before, our brains are not developing or growing as fast as technology. And let's see that nowadays we have a lot of problems with people, depressions, problems with alcohols, and let's imagine that in some years we will have cobots connected with artificial intelligence, smarter and wiser than us. Yeah, it is a real challenge for future. So thank you very much for your attention.
Dear Professor, thank you for your presentation, for your lectures. It was very inspiring for us. And personally, I agree with you with all of the aspects. But my question at the end. My dears, I open the discussion, the question for the presenter. If any, please, Professor Bato.
Thank you very much for this inspiring talk. As you see, you portrayed the Industrial Revolution starting from the US and coming up. And how many years did it take? From the first one to the second one, to the second, third, the third to the fourth. And in less than 10 years, you guys knew it.
Yeah.
Why is it that it is about the resilience of European industry?
Resilience.
Yeah.
Yeah.
The last two were resilience of European industry. The Industrial Revolution happened around the world.
Yeah.
In Europe.
To be honest, I don't know, but it's a really good and important question because resilience is one of these pillars of, let's say, Industry 5.0 evolution. I thought about it, but I don't have an answer for this. Why, let's say, I thought that it could be a question of pandemia, but I don't want to answer this question because I don't know exactly. Okay.
In 5 years, we'll have Industry 6.
It depends on on many things. Yeah, because as I mentioned, Industry 5.0 is a question of European Union. Industry 1, 2, 3, nobody talked about it. Yeah, nobody defined. When in 2011 Germany says we have Industry 4.0, everyone thought, oh, what was the first, second, third? We have fourth, and now we have fifth. I saw some, let's say, not maybe very serious papers, but we can also see that some give some ideas for sixth industrial revolution. But it's a question of let's say definitions. It's not difficult. It's not easy to let's say define it properly.
Dear Professor, I think it depends from the point of view. It's a lot of aspects. We talked about Industry 4, 5, 5.1, 5.2, etc., etc. That's something, but from my point of view, I'm a robotic man, rather. It's rather, but you said, we don't discuss about the evolution or the revolution. We discuss on the document 5.0, which is prepared by the European Commission, etc., etc. But from my point of view, of course, we forgot in Industry 4 with the human. We forgot about the human.
It's
that's true. Enough for the discussion, I think. Another questions?
Maybe I can also, when talking about my opinion, I think that the real fourth industrial revolution will be artificial intelligence. Yeah. So it will be when we will discuss about it in 20, 50 years. So probably it would be, as I listed, the three first revolution. The fourth will be connected with with artificial intelligence, not digitalization and so. But because industrial revolution, artificial intelligence is nowadays the most challenging.
Yes, Professor, you have right. Probably you know the company BMW, Mercedes, Tesla, and another few companies, automotive companies from China tested the human robots in his factory in the logistic area for a very simple task. But it starts. The artificial intelligence is very important today and have very big impact to our life in industry.
Yeah, absolutely.
Thank you, professors. I didn't see any questions. Thank you. Dear Professor Arkadiusz, that's of course, the certification for you. Thank you once more for your very inspired and nice presentation. Once more, bravo. But at this moment, I would like to invite our next researcher, Foivos Psarommatis, who represent the University of Oslo in Norway. And Foivos is a passionate manager and a highly attractive researcher in the area of quality management and sustainability in the manufacturing system. Currently, he is the founder of CIO of Zetek, a company based in Switzerland that focuses on providing digital technologies for sustainable manufacturing in ducting dynamic production scheduling and digital production passports. Our researcher presents the speech on the subject quality management in the era of Industry 4 and 5 towards zero defect manufacturing. Please, the stage is your microphone. Let's start.
Thank you for the introduction. Okay, thank you very much for the very nice introduction. I'm very happy to be here and see new faces and start new collaboration, as we said. So my name is Foivos Psarommatis. And today I'm going to present you some part of my research and some part of the things that we are doing in my company. So in order to bring some important things to the table to discuss it and to show you how we can think forward. So very briefly, we already said I'm from University of Oslo, where we are developing modeling languages for data structuring and semantic interoperability. And also I have a company based in Switzerland for supporting industry towards the digitalization using new technologies and making manufacturing domain more sustainable. So I would like to start with a question. So the focus is on quality. So what exactly is quality and what are the different aspects of quality? I think that when I say quality, the first thing that comes to most of your minds is product quality and what happens in the actual production. But it's not all the story. Quality is in the entire organization structure. It is also the product quality, but it's the operational quality between the different people, departments, on the entire structure. And specific attention needs to be given and to assure that quality and on services, on products, it's happening on all different domains in the company. So managing the quality, it's a continuous pursuing of excellence. So it's not something static, but it's something dynamic and constantly changes based on the different circumstances of the current period. Oh, sorry. So thank you, the previous presenter, for introducing the different industrial revolutions. I will not take too much time because we already discussed it. So my opinion on Industry 5 is that it might not be a complete revolution. It's the same technologies from Industry 4, but with a very important aspect, the human introduction back to the production, and not only about caring about the performance of a system, but also caring about the working conditions and many other aspects concerning the human aspect. Okay, so that's the basic. So I'm bringing up this in a chronological order because it is important to, in the next slides, to see what is happening in terms of quality management. So when we talk about new technologies, we have the tendency to forget something. Okay, when new technologies come up, we are very fascinated working with them, but there is always something that we are missing. Can you think what we miss when we try to implement new technologies? So we tend to use new technologies with old methodologies. So these things might not be compatible all the times and might not be fully utilize the new technologies, meaning that we try to implement quality management in using a traditional, let's say, quality management method with artificial intelligence, which those two cannot go together at the now because they have different, let's say, philosophy behind. One, it's, let's say, statistical driven. The other one, it's pure data driven, but for the entire batch and not in a statistical. So we have different tools that give us new capabilities that are not compatible with the old ones. And why I'm saying that? So I put in chronological order the different quality management methods that are being used very widely. So we start with total quality management that started in 1926. And then we had theory of constraints, Six Sigma. Six Sigma is still being used, and it's a very powerful tool. It served very well, but it's not 100%, let's say, compatible with the new digital technologies. So we are not exploiting 100% the new capabilities that we have. So if we move forward, we have Lean Six Sigma, we have also digital Six Sigma. And as we can see, in 2011, we have Industry 4. So we see that all the technologies developed in 2011 were unknown in the past. So those methodologies don't take them into consideration in their core of the methodology. So what should we do? Should we, let's say, erase this and start something completely new? It's not the case. So in 2017, there was, let's say, another movement created called Quality 4.0, which was, let's say, some consolidation of all the different technologies related to the quality management. And then in 2020, the term zero defect manufacturing came up and starting replacing the old traditional quality management methods with the new one. But it's not 100% new. It's, we take all the good capabilities and ideas from the past methods and put them in one new method that take advantage of both the new technologies and the good practices of the past in a more sophisticated and more efficient way. So let me introduce you what zero defect manufacturing is. So this is the basic, let's say, framework of zero defect manufacturing. So it's very simple. It's four main strategies, which is the detection, prediction, repair, and prevention. So with those four items, we can do everything in the production. So everything starts with the detection. So we identify, we collect information, either from the product, the production line, anything. So this is the basis. And then we have two options. Either if there is a problem, we may try to fix it. And using the data from the detection, we will try to prevent faults in the near future. Okay. But we already have a fault, okay, because we have detected. Now, where Industry 4 comes and the artificial intelligence and all the learning methods, we have the prediction. We are using information in order to predict when something will come in the near future, so we are preventing it. So we are not creating the fault in the first place, so we are more efficient, more sustainable, less waste, and better performance. So one of the key differences that zero defect manufacturing implies is that we are doing 100% inspection of the parts. And why we do that? Because technology allows that. Because we have vision cameras, we have other methods to identify if there is a problem or not. And just to give you an understanding, this is not this is a method that it's currently standardizing. So it's under standardization by the European Standardization Organization, CZECH, and also the German one, the DIN. So the first standardization working group has finished, and the outcome was the terminology that is associated with zero defect manufacturing. And currently there is the second standardization round, which is the standardizing the basic principles for implementation of zero defect manufacturing. Moving forward, I want to show you how zero defect manufacturing can be applied and how we should think as an engineers to implement quality management. Okay, because the whole point is to assure the quality and be sure that there are no defective parts to the customer. So you have less waste, so you have more optimized production. So there are two different ways of implementing zero defect manufacturing. One, it's called product oriented, and it's, as the name says, you start from the product, you inspect the product, and then if there is something not good, you go back to the process and you fix the process in order to make acceptable parts. And the other way is to monitor the process. And if the process is according to the specification, then you will be indirectly sure that the product is up to specifications as well. So, but both cycles lead to zero defect manufacturing. In other words, the product-oriented, you might consider it as, for example, predictive maintenance. So it's that part. And now I would like to show you some statistics from a very deep literature review that we did about what kind of research is happening through the years for the different zero defect manufacturing strategies. So as I told you, we have the detection, repair, prediction and prevention. So you can see that the majority, even now, the majority of the research is focusing on identifying that there is a problem and not focusing on the rest one, which this needs to be changed. Currently, we conducted a literature review this year, because that was in 2020. So we saw those numbers to, it's not published yet, so that's why I don't have the numbers yet, but it's quite similar picture. Slightly improved the prediction, but not very much. So this means that we need to think how we can best utilize new technologies and what we can do with them. And another thing is that as you remember, zero defect manufacturing had detection and prediction. These are the triggering mechanism. This means that they tell you that there is a problem, and then, but if you implement only these, you have nothing. You just know that there is something. You need to implement also something to counteract those problems. So the majority of the research done, they are examining each strategy single one, meaning that they are implementing either detection or prediction or repair or anything. But what is the point is that we need to, when we conduct research, we need to think in a holistic way, meaning we should provide both the detection and the prevention, for example, in order to be able to show what exactly is the outcome. It is very important. And now, again, regarding the technology and the capabilities that technology gives us, we have two different types of detection, two different types to inspect a part. We have the physical detection, which is using a CMM, using a vision system, or something that you have a physical access to the part. But also we have what is called virtual detection, coming from the virtual metrology domain, which is you collect the data from the process and you are able to estimate what is the quality of the part. So this means that you don't spend time to quality inspection. So this means you can optimize even more the production, and you can achieve 100% inspected parts, and at the same time assure that the quality is at the levels that you want. Now, it is implementing quality management. I know that it's not a straightforward task, but many times we have the tendency as researchers, as engineers, to think on the production level and forget what happens in the other business level. So many times we implement some solutions to a specific problem without considering what are the consequences of this implementation to the rest of the production. For example, if the production goes out of balance, or if from the business perspective there are some inputs that we didn't consider. So my point here is that we need to think in a more holistic way and to think on different levels of the production. And in the next slide, it's what I mean, because we implement new technologies, but we don't know what is the outcome to the actual production. So we think that the linking chain between the different technologies, you see the business and production decisions, we have the supply chain decisions, we have the industry 4 technologies and whatever we can do, and we have the quality management. All those are connected by one component in the production, and it is the scheduling, because it's all about time and it's all about coordinating the different activities that are happening in a production system. So when you, in the next slide, I have, actually I will go to the next slide because I have a very interesting, let's say, example to say what are the new requirements that new technologies give us. So we talk about predicting defects or faults in the near future. So this means that the production system should be more flexible and adaptable from what is it right now, because if you predict that something will happen in the next, let's say, 5-10 minutes, you need to be fast to react before this time comes, because if this time comes, you will have the defect. So this means that you need to reschedule in a dynamic way in order to accommodate the different needs that are required for counteracting what you have predicted. Okay, so it is very important to embrace the new technologies, but at the same time create new methodologies for handling them. Because right now, where the majority of the production there have fixed schedules, or they have daily, weekly. So this means that they cannot adopt such implementation. And if they implement, and if they invest to such implementation, they're going to fail, or they're not going to get back what they wanted. Okay, so that's very important. So I would like to show you some results that we had in a use case in a semiconductor factory in the UK that we actually implemented a dynamic scheduling mechanism for their production line in a specific cell. Using the traditional, let's say, rescheduling policies, and what they had also at the factory. Actually, they do it every 3 days in that factory, but we simulated the rest of them. And with yellow, you can see we have developed a dynamic scheduling algorithm in order to manage those activities with a prediction. And we succeeded to have more than 21.1% improvement to the schedule, which they were very amazed because they haven't thought that implementing prediction will require different scheduling policies. And this is what I said at the beginning, that new technologies require new methodologies or updated ones. Okay, we shouldn't forget the past. We should embrace the knowledge that exists and update it or upgrade it, in other words. Is my time out? Yes?
5 minutes.
But the presentation, it's 18 minutes here in the
18?
Yeah.
18?
Ah.
We have time to the 11, and we have once more Keynote speaker.
Okay. Okay.
Please, a little bit closely.
Okay. Because I see here. Okay. No worries. So how do we select, let's say, the most appropriate, let's say, equipment for achieving zero defect manufacturing? So what we have done in the past in the same use case is that we made a digital twin of the production, and then we, let's say, we had those factors here for the detect repair policy, for example. And we simulated more than 500,000 combination of equipment specification based on the KPIs that the manufacturer wanted. And then we were able to select the top specifications for the equipment in order to have efficient zero defect manufacturing. And now we need to talk about data, because Industry 4, Industry 5, it's about data. Without the data, we have nothing. And actually, without structured data, we have literally nothing. But at the same time, we need also data transparency, that things are happening as they say. And also, we need traceability, because data traceability is a vital point for training AI, machine learning, and so on. So we can correlate data with facts, with products. The biggest problem that I think all of us we have is that we cannot correlate accurately products with data. So what's the solution? The solution, again, introduced by the European Commission, it's called a digital product passport, and it's nothing else but a centralized, let's say, source of information per product. So this correlates, so while we log data, we immediately correlate it with a specific product. And this product, this passport, let's say, this identifier follows the product through the entire life cycle. And here are the different, let's say, stages in the life cycle of a product. So we have the raw materials, components manufacturing, which are the normal production process. We have the product use, which is the usage phase. And then we have the remanufacturing process. And then we have the recycling process. So the digital product passport is, and of course, about logistics and warehouse management and many more. So we can see here what type of data are stored in the digital product passport and at which stage of the product life cycle. So we have material data, environmental, manufacturing, value network, supply chain, maintenance, circularity, and the end user data. And here it's another example about the implementation of zero defect remanufacturing, because when you remanufacture, you have to inspect 100%. So it is a good case for implementing zero defect manufacturing. And at the same time, we have implemented digital product passport, and we have achieved 25.3 more efficient decisions, and we reduced the remanufacturing time more than 39%. And that would be my last slide, because we talk about Industry 5, we talk about human centricity, we talk about digital technologies. Humans will always be present in a production and always will be needed. And at some cases, they are better than the AI. But how we use the AI and the digital technologies is not only for the performance of a system, but also assuring that the working conditions and the health of the operators are at certain levels. So what we have done in this research is that we have implemented, we are monitoring the gesture, the position of an inspection operator, and we suggesting him if he stands correctly or what should change in order not to have problems in his or her body. So that's it from my side. Thank you for your attention. I hope you enjoyed it. I'm open to questions.
Bravo. The first time, bravo. Thank you, Professor, for your presentation. Very inspired for me. The question? Oh, here was the first.
Yeah, sure.
Okay. I think you know the idea of zero defects belonged to Phil Crosby. It was his idea, zero defects, and he developed it, seems to be more than 60 years ago. Could you stress the point, the difference between your ideas, your approaches, and this classical Crosby approach? It's the first question. And the second one, your idea about design of ZDM methodology, for me, it looks like Taguchi idea. Why not you use Taguchi idea but develop your own? And is there any difference, principal difference?
Okay, thank you very much for your questions. First, about Crosby, okay, they have a lot of similarities. I said that it's not something new, it's something upgraded. So we are using all the philosophy and all the points that Crosby said, but we modernize it in today's period, because when Crosby introduced that, the technology for implementing was not there. So he didn't know what technologies we will have now. So it was only an estimation or a vision. Okay, so the differences are on how you can utilize the modern technologies in order to achieve zero defect manufacturing, having in mind all the previous methods that exist. And regarding the design for zero defect manufacturing, yes, of course, we used Taguchi, and we used it because it is efficient, it is lean, and it's very accurate, at least in this case, and it reduced the computational time significantly. So there is no need to invent, let's say, the wheel of something new when we can use something and to have great results.
Okay, thank you. Thank you for your presentation once more, Francisco. And of course, the certificate for you, please. Very nice. Oh, photo. Okay. And okay, thank you. And this for you. Okay. Thank you once more. Bravo. My dears, the times go so quickly, and our third keynote speaker, I invite Francisco Silva, who represents the Polytechnics of Porto from Portugal. Currently, he is the head of the Mechanical Engineering Research Center at the ESAP Polytechnic, of course, of Porto. Dear Professor, the stage is yours, the microphone is yours. Please start.
Thank you so much. Good morning, everyone. Thank you for the invitation. I'm so happy to be here to talk for you about an important topic, namely green automation. I think it is not working. Okay. Thank you. About the contents, I will talk about green principles, sustainable development goals, and the corresponding policies, how automation can become the world greener, automation applied to manufacturing systems, additive manufacturing, advanced coatings, green technologies, smart manufacturing, green automation, and some case studies. About green principles, there are some key topics. Namely, the world population continues to grow. Growing population is more evident in developing and undeveloped countries. Economic activity is continuously increasing. Financial availability of families is in developing countries is higher. New consumption behaviors are growing. Environmental education is not developing at the same velocity of the previous factors. So there are also some green principles that we can take care, namely moderate the consumption, increase green design practices, reduce waste generation, increase refurbishing, reuse and recycling, increase environmental responsibility, environment education must grow, technology can help educating people, and technology can help in saving researchers. I think these are key ideas that we need to take care in the future in order to increase our responsibility in terms of make the world greener. the consumption patterns are changing, and we need to improve the consumption pattern in terms of make our attitude to the world better in order to decrease the generation of waste, to decrease the consumption of energy, to have a more responsible behavior in our world. In terms of environmental responsibility, we need to have more care about how our consumption pattern is evolving, and I think we have a strong need of education about environmental education. In terms of sustainable development goals, maybe you already know this slide and these principles. I will be focused in the ones with the circle: clean water and sanitation, affordable and green energy, decent world and economic growth, industry, innovation and infrastructure, sustainable cities and communities, responsibility, consumption and production, and climate action. But we have some challenges here because we are talking about creating more and strong economic behavior in terms of the countries and so on. The governments are talking usually about economic growth and so on, but economic growth is parallel to consumption, and consumption is spending more energy, spending more resources, and so on. So the compromise, the balance between these ideas is not clear and is not easy to make them compatible. In terms of current main focus, we can take care of the growth of economies. It is a topic of the politicians' speech that we can hear every day. Company profits. The companies are mainly focused in results, positive results, of course. Distribution of dividends by shareholders is also a concern of any company. People highlighted by ostentation, so maybe you have already observed this behavior. Economic interest above social interest. So we are discussing the pillar of sustainability about the social problems and so on. But many responsibles of the companies are not taking care of some social interests. Labor exploration, contempt for social inequity, corruption, and conflict of interests and war. I think these are some of the main problems that we are focusing nowadays. There are some questions of difficult answer, namely, it is possible to grow the economy without increasing consumption. I think it's something that we need to reflect a little bit. Is it possible to increase consumption without increasing pollution and waste generation? I think it is a new challenge. What efforts do we make to consume sustainably? Is sustainable consumption compatible with economic growth? How will it be possible to distribute health and more fairly, rewarding those who take the initiative and covering business risks? How can we educate new generations to prioritize the consumption of natural goods or those with a lower degree of processing? How can we raise awareness among new generations about environment preservation and sustainability? I think these are some of my concerns about how we can balance the economic growth, the population growth, and the environmental concerns that we need to take care. How the automation enters in this kind of concerns. We can take care of the agriculture activity, namely minimizing water waste, make a good selection of the use of pesticides and fertilizers. Automation and artificial intelligence strategies can be implemented in order to improve the productivity of the agriculture. Automation and artificial intelligence can be applied and fill the labor shortage. And resorts and golf courses and so on can be monitored in real time in order to decrease the consumption of water in order to make the process greener. In terms of construction, the construction sector is not complying with some objectives that we are talking about in previous years. Managing the energy spending in construction operations is not properly cared at the moment. Additive manufacturing can be applied to the construction sector and can increase the sustainability of the sector. 30% of global green gas emissions are providing from this sector, and assertive strategies for smart buildings can lead to water savings and also power energy consumption. In terms of services, we can also design or reformat companies' operations in order to save resources. Can potential to reshape the product's life cycle. Can extend the product's useful lifespan. Smartphones can be adapted to more apps that can help us to monitorize and to manage some activities in order to save energy, to save water, and so on. And reducing paper consumption because the recycling of the paper is not so successful as we can imagine. In terms of automation applied to manufacturing systems, there are a long way to do. The industry is responsible for about 90% of energy consumed worldwide. About 7 million of deaths worldwide are generated by the industrial sector. about 100,000 premature deaths per year are resulting from industrial activities, and immense amount of plastic that is dumped into the sea is also providing from the industry. So we need to make the transition to a better future, and some ideas can be implemented. Namely, environmental care should be started in the product definition phase, in the design phase. Supply chains are producing 11 more emissions than the production activities. So we need to talk about globalization and so on, but the logistics is also an important part of the problem. Energy consumed in the production of a car represents about 9 to 12% of its total manufacturing cost, and reuse and the refurbishing should superimpose to the recycling and landfill old products. How can automation help in these concerns? In 2021, more than 100,000 new robots were installed in the industry. This is a positive factor. Automation and robotics can help regarding the three pillars of sustainability. Dangerous operations can be assumed by some robots, so the people can be cared, and we are talking about the social pillar. And the reconfiguration of equipment, changing jigs, feeding of different materials or components, waiting about the sensing position and so on. We can make real progresses in terms of how the automation can help us in make the world greener. In terms of smart manufacturing, we are talking about several sectors. I'm focusing in the chemical industry, because chemical industry, as you know, is a problem in terms of pollution and so on. And there are some developed ideas about how the manufacturing process can be cared in order to improve the environmental preservation in terms of industry. In terms of smart manufacturing, control of raw materials variation can be applied and using automation. Sharing acquisition of knowledge can also be cared. Data needs to be combined coming from different sources. Strategies to make the process dynamic and take care of the risks assessment and so on can also be performed. Powerful information support systems are also needed, and the interconnection of activities is controlled and managed in real time, so automation can take a crucial role in this case. In terms of additive manufacturing, it is a disruptive process, almost fully automated, uses a wide number of techniques and materials, is a design freedom process or technology, applies materials only where it is absolutely necessary, so we are saving resources, reduce emissions, and support and the scraps can be recycled, and requires less human efforts, but can bring some health problems, as some of you can saw in the last day, where the powder of the process can be harmful for the humans. In terms of advanced coatings, maybe you have already contacted with many tools or many goods in our homes that are partially manufactured by advanced coatings. So we are using as advanced coatings chemical vapor deposition and physical vapor deposition. It is a process fully automated. PVD uses inert gases, so it is not harmful for the environmental. CVD can emit some harmful mixtures of gases, so it is not so green than like the PVD process. Some cleaning operations are needed and are producing some harmful products. So some challenges in environmental terms need to be cared. Save materials researches as well, improve products lifespan, and reduces energy loss due to friction. So it is a green technology that can be applied with some minor risks. In terms of greener technologies in other manufacturing process, we can talk about the steel industry, where steel industry is consuming a lot of water and a lot of energy. So some automation processes can be applied in order to save energy and to recycle the water in order to decrease the consumption of water. Construction industry is also a concern because it's spending a lot of energy and producing a lot of wastes. So maybe we need to take care about this industrial sector because construction is the research about the construction is not so developed than we would like. Pulp and the paper industry is also producing a lot of or using a lot of chemicals and consuming a lot of natural resources and a lot of energy and water. So it is a less green industry. Maybe some research is needed in this case. And textile industry is usually well known by the chemicals that they are consuming and generating, and the treatment of these chemicals about after the process is not so good as we need. In terms of green automation in our family and home, there are some cares that we can take in order to improve our life regarding the environment, namely saving water, and there are automation processes and automation applications and so on in order to increase the water savings. Energy can be improved and can be efficiently used at home in order to decrease the consumption of energy. Heat, we can use water pumps, solar panels, and so on in order to decrease the heat needs, and light. We can take care of the design and positioning of the buildings in order to take more natural light and so on. We have developed some case studies in the companies in order to make the industry greener, and I would like to show some examples of these cases. There are many robots that are putting out of service, and they can help in other activities in order to improve a lot of activities. And we used a robot, old robot, out of service to perform welding operations in large structures for a bus manufacturing company in order to decrease the labor applied to the process and decreasing the quality problems around the process. So we can reuse these robots because the process is not so demanding in terms of dimensions and so on, and the robot can perfectly perform the activities that we need to develop in this case. Another process is in the plastic injection industry. Also, an old robot out of service was used to make a full automated process of assembling some parts in pre-injected parts of cars. And in this case, we are producing cables that we use when we open a door in our car and so on. And with automation, we can save time and save quality problems and save labor applied to a process that is easy to perform in terms of full automated systems, and saving resources for another activities. In conclusion, it is urgent to look at the environmental concerns. Automation is contributing for this. More education and awareness of the global population is needed. Consumption could be reduced. Reuse and refurbishing should be increased. Some technological advances can take place and maybe focus in large consumptions and should be moderated. More apps for smartphones and so on about energy control should be developed. Natural resources should be preserved, and we must pay more attention to all around us, damaging the environment, and be more active intervening when others are damaging the environment. These ideas are exposed in my more recent book. You can find this book available in the next 2 weeks. So I invite you to see some ideas in this book. It will be published by Talleyrand Francis. I would like to thank the support of Solid Journal, and thank you so much for your attention.
Dear Professor Francisco, thank you for your very nice and inspiration presentation. And now it's the time for one question the next, please, on the hall, on the coffee break. Please, Professor Andre.
Thank you for such a nice presentation. I don't have a question about it, but if you go back to your first slide, you're just trying to correct one word that is politically not advised to use. Your first slide, you mentioned developed and undeveloped. The word undeveloped has been agreed not to use for these countries. It's rather to use developing country, rather undeveloped.
Okay.
Because some people get really annoyed with that word.
Okay.
Because in the group of undeveloped countries, there are countries which are like the BRIC countries who claim not to be classified that way. So this word may affect some people.
Okay, I agree with you.
Did you say pollution or population growth?
We are talking about population growth.
Population growth, in that case, you say that the population growth is more evidence in developed countries. The statistics show the opposite.
Yes.
Because
yes.
the blooming, growing population is in developing country, not in advanced countries.
Yes, you have reason.
So why you put in your presentation that way?
No, we are talking about two realities. In developing countries, the populations are growing. And in developed countries, the populations are decreasing and are controlled. So when the education about environmental is more evident is in the developed countries.
Yeah.
In developing countries, the education, the awareness about the population about the environment is not so good.
Yeah.
So we have some problems in balance this, because the population that is seeing the problems are decreasing, and the population that is not so aware about the problems is increasing. So this balance is a concern.
Thank you.
Thank you. Of course, Professor, the balance is very important, and of course the sensibility, all of the aspects who you present us, it's very important for our life, for our production, for everything, and we should think about it on each our step in our life. Thank you once more. Of course, that's the bravo. Let me give you, the certificate. My dears, I would like to thanks for all of you. Thank you for your participation for the first session. I would like to say a lot of thanks to the organizer, to the Professor Ivanov, for my person was the chairman on the Keynote session. That's a little bit some tradition. Thank you once more. And my dears, I think it's a time for coffee break. Please enjoy. Thank you.
new materials, intelligent manufacturing systems, smart mobility, biomedicine and medical technology. These are the main fields in which we pursue research, development and innovation in the Pilsen region. Create your future with us. Innovate with us. Our region has a history of innovation. Important trade routes have always led through here. The first book was printed here. The first electric lamp was lit. We've seen dynamic developments in transport and new fields of medicine. Two of the world's leading brands, Škoda and Pilsner Urquell, were created here. We are successfully continuing this tradition. We are a region with traditionally strong industrial players, innovative companies, and major university institutions and successful research centres. But we're not just an industrial region. You can spend your free time wandering through the countryside or visiting historical and industrial monuments. You can be active or relax with great food and great beer. There's something for everyone. Here in the Pilsen region, we're involved in materials engineering. Research into metallic materials, 3D printed machine tools, special steels, the research and application of thermal spraying, and new technologies for the forming and heat treatment of metals for mechanical engineering and the automotive and energy industries. For example, if you ever come across a smart window which controls the amount of thermal solar radiation passing through depending on temperature thanks to a special coating, this patent originates from research at our university. Manufacturing, power plants and industry in the Czech Republic and abroad use intelligent control systems designed by engineers from innovative companies from the Pilsen region. The university's Research Technology Centre is developing completely new applications for contactless thermal imaging measurement, and not only for industry. Sophisticated computers that are built into medical devices are saving people's lives, and they're also being used in industry, transport and aviation. Smooth running. Let's take a look at another rapidly developing field, smart mobility. But we're not talking about just developing new electric drive systems. This is about a whole range of technological innovations for the operation and management of urban traffic, wireless charging, autonomous systems testing, and transmission development. One leading field we're dedicated to is biomedicine. This focuses on research and development in the fields of organ replacement and regeneration. This includes research into the prevention of viral infections after kidney transplantation, as well as research into antibiotic resistance. Specialist software is helping to diagnose and treat liver cancer as sensitively as possible. Software and diagnostics are also helping to prevent transport, medical, and sports injuries. Create your future with us. Utilize the potential of the Pilsen region. In practice, in research, at the university. There will always be innovation. Let's succeed together in the world. Innovate with us. The Pilsen region, the best place for innovation.
thread speaker, speak about important cooperation between industry and research institute, university, and another person. On the start, we can prepare presentation metal additive manufacturing in tool making. Professor Miroslav Zetek is expert from University of Bohemia, Faculty of Mechanical Engineering, and Miro, pojď. And stage is yours. And how many minutes?
15.
15 maximally.
In program is 15.
Okay. Miro, please.
Okay. Thank you. Thank you for a short introduction. Ladies and gentlemen, dear colleagues, it is my great pleasure to tell you some few words about our research on our university, in this case in our Regional Technological Institute, which is a science center of Faculty of Mechanical Engineering. For this time, I just prepare a presentation about the area of toolmaking, and I just divide it into two phases. I just will be focused on cutting tools and into the area of injection of plastic material, and how the additive manufacturing, in this case from metal materials, is used in this area on our department. It is a very nice, this section is called Business to Science, and I just introduce and show you how our science we implement it into the business. So now we are going to some few words about the Regional Technological Institute. Generally, we are focusing on a few 6 main areas, and one of them is, of course, additive manufacturing. In this case, for today, is a metal from materials. For this area, we just use for today 3 machines. The main is a middle size M290 with the size of 250 and 320 millimeters. And we are generally focused into the area where are mergering steel, Inconel 18 stainless steels, and nickel-based HX are used. So it means that our main industry partners are from area from general industry, automotive, aerospace, space, and of course an energy industry. In our department and Regional Technological Institute, I can say that we have all necessary infrastructure which is needed for solve a complex problems for industry and of course for research and development. So this is our very huge advantages because during the developing I can very correctly and deeply see what's happened during the process in all times with the samples or with the some developing new systems. Our domain is that on one device we have implemented institute monitoring systems. It means that it is possible to see during the time and during the process what happens in the melting area of the metal powder, and on the base of it we could identify and indicate some possible defects which could be inside the body. For today we have our own algorithms to identify the possible defects, and in a new project we want to solve the use of artificial intelligence to predict the defects and to use it for adapting optimization process during the process. It means because during these techniques normally 3 layers are remelting during the 1 layer. So it means that we have and next 2 layers for the optimization of the possible defects which could be inside. and we need to adapt the process parameters continuously during the process. What we see on these systems is some inhomogeneities on the base of some thermal processes. Here you could see some few things. For today, on the base, when we do some production for our industry partners, we could use these systems for continuous monitoring of the quality of the 3D printing of the parts. And of course, if we have a print much more samples for our partners, for the next print on the base of the evaluation from these systems, we could do a little bit optimize the process parameters. But of course, sometimes I heard we just optimize the process parameters for the 3D printing. It is possible. It seems that it is a very easy process, but it is very dangerous because if we change the process parameters, we could generally to influence the mechanical properties. What is from my point of view, is a little big danger is that a lot of companies do only tensile tests, and the tensile test seems very good, and so I did optimization of process parameters. I have had the good results of tensile tests, so it is everything fine. It's not true, because if we do the fatigue test, we will see what's really happened and how we to influence the total life of the parts. So this is what is a little bit danger in this area of the optimization of the process parameters. What is one of the disadvantages of the metal additive manufacturing generally in our technique, powder bed fusion? It's residual stress, which are generated during the process because the thermal processes inside is too fast. So it's generate a lot of high volume of the tensile stress. Here you could see a normal process parameters, and you could see that the stresses, tensile stresses are too high, and it is influences by the amount of the melting material in one layer, of course. So this is our main area for today's developing, and on the base of our new outputs, we could say today that during the process, on the base of the process parameters optimization, we could print the parts with a very low volume of the tensile stress, and we are very close to have a compressive stress during the process. What this mean? It means that the deformation are much more smaller, and when we implemented this new process parameters to very complicated parts, it is possible much more easy to print these parts before, for example, half years ago. So, but what is our last step? How you could see in close area of the surface, we still have a tensile stress, and of course, in combination of the surface quality after the printing, it's still little danger in area of fatigue life of the normal of the parts, of course. So all our knowledges we implemented to benefits for the additive manufacturing. So we implemented, of course, some lattice structure into the body. We use for a production topology optimization. So some bionic shapes, which is sometimes very complicated. And a few times ago, it was very complicated to do a correctly FEM analysis of the parts. So on the base of our knowledges, we developed together with company Altair the special macro where we implemented the correct values and we optimized the FEM analysis. And for today, we could calculate it very correctly the parts where we implemented, for example, lattice structure. Now we are going into some application into the area of the cutting tools. Our department have a lot of experience and outputs in this area, and I just show you only a few main outputs, which is very usable for the industry and bring some benefits of it. The first one are the area of very light tools. We use a very specific construction. Of course, when we apply topology optimization, we created a special tools. But what is a main advantages is that we save more than 50% of the materials according to the original tools. For the next, all the construction generally are optimized for the production by additive manufacturing. So it means that the construction are according into the printing strategy, and we save, for example, supporting structure and so on. And of course, for the machining, there are a minimum materials, so the final products consume or generate a minimum amount of the waste materials, which is very important for today's. And the special construction, of course, brings some benefits for the machining. Generally, the main points is, for example, increasing of the productivity, increasing of the tool life, and of course the other things. Here you could see some application in area of high-speed cutting of a very hard materials. We implemented these tools to one company which is focusing for machining for a mold and die with high hardness. And we can say that the benefits of these tools is that we coming the air cooling system to the rake and clearance phase, and the workpiece is still too cold. So the accuracy of the machining is much more higher, and it is much more productive. This next generation is a special tool with 3 or 4 edges for linear cutting, for the linear machining with the point edge machining, and the same area is a area of machining of thermal spraying coatings with high hardness. You could see here that is a 60 Rockwells. What is the benefits? Of course, I just go back if it's possible. Yeah, the benefits is a cooling system because the cooling is by air too. So it's a machining without liquid. And the normal process for machining of thermal spraying is grinding. And we remove the grinding for we can say turning. So we save a lot of time, and we save a lot of liquid which is necessary to use during the grinding process, of course. And the accuracy and surface quality is same, sometimes better than after the grinding, which is a very famous result from our point of view. So the last cutting tools which I want to show you is system Echo. We use a standard body, but we implemented here these 2 special nozzles which is produced by additive manufacturing, and we use the cooling for a clearance and rake phase too. So here you could see how it works. And the orientation of the liquid is much more accuracy, and we implemented it into the companies where machined titanium, Inconels, and so on. So area of the aeroplanes and so on. And the saves are much more than 100. So it's a fantastic, and it's based on the special cooling. And the last industry application, of course, is injection. We use the benefits of the additive manufacturing. So we implemented the lattice structure. We implemented, of course, the system for a cooling or heating. It depends on the application. But in this application, we are going to production of this part. It is a NIP for connecting the rear lights for automotive. This is the part from a plastic. And into the tool, we implemented some different inside holes, but it was very difficult because the thickness of the tool was only 3 millimeters, and you must implement it into the 3 millimeters inside hole. So it was on the edge of the printer belly and some internal quality of the tool, but it was very nice, functional. And how you could to see on the simulation of the cool rate, you could to see that during the implementation of the inside cooling with a very small size, the cool rate was much more higher. So it means that we could to save a time for the production. So now we are going for a result because of course we implement it in the normal production line. And here you could to see that this is the original time, 13 seconds for one step. And with our tools, we save 4 seconds. And of course, we save and reduce some non-conformities because the deformation was much more higher than we implemented the new tools. So we save a time approximately about 30%, and we decrease the non-conformity about 60%, which save a lot of materials and of course a lot of monies during the time. So quickly and short introduction to our work, and thank you for your attention.
Thank you. Have you some question for this interesting topics?
Thank you very much for this interesting presentation. The tensile stress and the compressive stress you showed, is that after heat treatment or before heat treatment?
The results.
The tensile.
It's after the print. It's after the print without the heat treatment, because this is one point. The heat treatment after the 3D printing increase the time and increase the money. So our main point is to optimize the stress during the process and minimize the necessary next step, which is the heat treatment.
So what will happen if your powder is not homogeneous in terms of size and you may have some voids, some porosity? How do you deal with that? Because the one layer came, your scanning is on the top, you see only the top layer. But what's happening with the recrystallization of the previous layer? Your scan cannot see it.
It's a very good point, of course. This is the disadvantages of this systems, because we see the actual layer, and the remelting of the same layer is next 3 times. Okay. So this is what we now still learning. If we check some possible, this is why I still say about the possible defects, because I'm still not sure if it's inside. But of course, we compare the results from our systems with CT scans. And on the base of the evaluation of the energy and so on, we connected the possibility prediction if these defects we will see on the base of the energy and so on, if still be in this site, in this place, sorry. So this is the main point, yeah.
You mentioned something very good. The other company just do tensile, but did you do bending test?
Yes, we did, and this is much more interesting than the standard fatigue, because the bending test is very complexity, and you could to see an original way how the crack will be processed. Yeah. You're welcome. Thank you.
Another question.
Okay. Could you please precise the cutting speed and feed rate for the milling process If I just missed this data, excuse me, please.
Yes, of course. The cutting conditions depend on the machining materials. What I show you for the tools, it's not functional now, sorry, I don't know why. Sorry, one more. In case of Inconel 718, because the results from the light tools, which I show you, was from Inconel 718, the cutting speed was 60 meters per minute, and depth of cut was 2 millimeters. In area of high-speed cutting, which was on the videos, the cutting speed in this case was about 300 meters per minute, and it is possible to machine on the base of the cutting inserts, of course. We could do from 300 to 600 meters per minute.
The high-speed milling, we sometimes have in mind a high feed rate. What amount of this high feed rate in your case possible?
I think in this case was high-speed cutting. So it means that we use a very high cutting speed with a lowest depth of cut, and with the same feed rate, which was 0.2 millimeters per feet. In area of the very high feed speed, we use 3 or 4 times higher, but with the feed speed, but with different geometry, which is modeling by tangential system, not actual like in this case. Yeah.
Thank you.
Co?
Díky moc.
Děkuji.
Půjdeme se do třetí. Okay, thank you very much.
Thank you.
Please, next presentation. I invite to Tomáš Cholinský on the stage. Just a moment. Because next Pilsen product is not only beer and heavy machinery and university, but I say this is a regional innovation system. And Tomáš is director of a very interesting infrastructure in Pilsen Tech Tower that introduce regional innovation system of Pilsen type. Please, Tomáš. Stage is yours.
Thank you. Hello, everybody. Mostly of you know probably Pilsen because of beer, right? Because this brand is one of the famous of all the world. But, you know, Pilsen is not only beer. We have a nice city center, we have rich history, strong industry, and we know how to play football pretty good. A couple years ago, the Pilsen started to focus for innovations. It means drones, digital twins, smart offices in the center, etc. It's great that you have the innovations, but do you know what's important? Important is you need a people. You need the people who can work with the innovations, who are smart, who are clever. It's why we prepare PINE, Pilsen Innovation Ecosystem. We work with the children, we work with the teenagers, students, and for sure with adults. The PINE has 4 main points. The first is support young talents. The second one is inspire experiments. The third is help startups. And the fourth is innovate and expand. Here, looks difficult, but it's the main organization and the main activities we do in Pine. And now I will show you all 4 etaps. The first etaps, we work with the children 6 to 15 by Center of Robotics. It means the children studying, working, but still smiling. Every year, like 400 children pass these activities. Mostly it's leisure activities like workshops, summer camps, etc. You can see the faces smiling. It's important for them. It's important for the parents, because if the children are happy and they are studying, probably they meet first time the programming, the robots, the technologies, and still they are smiling. Every year, like, we organize 40 activities, leisure activities like workshops for them. In summer, we have the summer camps. So we do a lot for them. We have the special place, Center of Robotics, where the children can come and do these activities. The second way what Center of Robotics focus, it's to help teachers how to work with innovations, with the trends, because after the teachers, they can show it to the children. They can work with that in their classes, and it's very, very important. Now I would like to show you one video, how we do it, from technology to nature. There is no sound, or we have it. If not, there are subtitles, so.
To the fact that we can work with bees in the robotics center, we can find cameras in the hives. We will also find some other sensors there. So we can actually collect data, we can work with them, our students work with them, but also elementary school students can work with them.
Cílem dneska bude zkusit si simulovat ty větrající včely. Pojďte mi k těm senzorům. V tom úlu je teplo a ty včely potřebují snížit teplotu. Do té destičky připojit tam OLED display, senzor teploty a ten motor s tím větrákem.
We can motivate children to be more interested in how nature works and how, for example, bees can help in our lives.
Tady dole ještě je takový grafík, měříme to nějaký hodnoty. Tak samozřejmě, když tam potom přibývá ten med, anebo i přibývají ty včelky, tak já to vidím. Pomocí těch informací.
Using the information we collected, we deduced what might be beneficial for the beekeepers, what isn't, and how it actually all works. Even the bees inside the hive.
Včely dělnice zajišťují nejenom to, aby tam byla správná teplota, ale i určitá vlhkost, jasně. Modrá je ta váha, červená je ta teplota uvnitř. Chomáče, děkuji ti, Vítro. Centrum robotiky.
The Robotics Center is mainly dedicated to educating children as part of leisure activities, but also to support kindergarten and primary school teachers here in Pilsen. The youngest children that come to us are preschoolers, and as for the older students, as high as year 9, from technology to nature.
So it was just one activity. We have it more and more. And what next? What next when you are 15 years old or older? You don't want to go every Tuesday for some activities with bees. You have your own life. You run after girls, after boys. You want to work when you want to work. It's why we made Sitport in the second phase. We work or we develop talents and inspire to businesses. It's children, mostly we call them children, but it's teenagers and students, 16 plus, high schools, universities, and pre-incubation startups, etc. During the year, we organize around 80 events for this community. Hackathons, startup weekends, we do our own e-sport league, we do podcasts, we do some videos, and other activities which are trendy for this community. For example, this picture is from hackathon with Swiss embassy, where the Swiss companies came, gave the tasks to the students, and they pass it, and it's great. And this community, we need to help them, we need to inspire them, we need to develop them, because after they will be stronger, they will be much clever, etc. Here, short video about the activities of Sitport and Phase 2. For this community, it's a very important place, the place where they can come and they can do there what they want. It's why City of Pilsen reconstructed the old brewery. We call it Tech Tower, the place where future is born. It's 10,000 square meters of offices, meeting rooms. There is a kindergarten and studios for podcasts, videos. We have our co-working place where, for example, last year were 200 people and it's first year of opening. We have our swimming pool, but it's not for swim, but it's for testing drones, robots, some prototypes. We have our garage, we call it garage, and it's a place when you can build your prototype, 3D printers, lasers, and all you need for do good prototype. But important is full house. These pictures are from our Tech Tower, from the activities like conferences, startup weekends, quizzes. There is a picture from the hydrogen car race. And how I said on the beginning, it's very important to place like this, because the people, the children, how we call them, they meet together, they start to do some interesting projects, and it means that startups begin. And now I will show you another video with some startups which are from our community.
Startups and entrepreneurship. Hello from Pilsen, I'm Petr. And I'm Marek. Today we're here to introduce you to a few local startups. What's a startup? A startup is a newly founded company that solves a problem in an innovative way. The world's most famous is probably Apple. In our country, maybe Miroslav and his Beat Saber, or here in Pilsen, for example, Social Bakers. Historically, the company Batya could also be considered a startup, so it's obviously possible to get somewhere, and entrepreneurship is worth supporting. And that's what's happening in Pilsen. Let's take a look.
You don't have to be Elon Musk to get help starting a business in Pilsen. Here, they know that about 2/3 of jobs in the Czech Republic are created by small and medium-sized businesses. They account for 1/3 of GDP and 50% of added value. A startup is all about a good idea that could be not only a regional, but also a global success.
Maybe you develop hardware and software solutions for coordinating drones in low airspace, like the guys from Drone Tag, who've won numerous international awards and support from the European Space Agency. Hi, Lukasz.
Hi, Marek.
Lukasz, what is the Drone Tag Mini?
The Drone Tag Mini is our tracking device that is specifically designed for drones so that they are visible on an air traffic map.
Is it similar to what aircraft have?
It's a similar concept, but this is something that's missing on drones, which has greatly limited their commercial potential.
This is Drone Tag.
In my hand, I have the first
FAA-approved device for remote ID.
And how does it work?
You can easily attach the device to your drone. Once the device is in the air, you can see its position, altitude, speed, and last but not least, its registration number, which actually falls in line with new European and American regulations.
The technology that's going to be required on all drones.
Man, look, it's pretty accurate. It really is.
So it has international applications.
That's right. It's even one of the systems that now allows for parcel delivery, for example.
Thanks, Lukasz, and keep flying.
Thanks, Marek.
Peter, what about NextDrop, another global startup? We're here at the Waterworks in Pilsen, where they use a unique system for monitoring and controlling the behavior of drinking water in the network. Ciszak, can you tell us more? Absolutely, I'd love to. Water is one of the most precious resources we have, and a sustainable water management system is a global problem. Our startup is trying to contribute to solving this problem by automating solenoid valves, one of the most common elements we use to control the flow of water. And what are you doing here at the Waterworks? In cooperation with Pilsen Waterworks, we're developing a unique technology for the detection of water leaks and micro leaks inside buildings. So you're dealing with losses. What about rainwater management? We're deploying our solution at Pilsen Zoo, where our system controls and monitors the management of rainwater for greenhouse irrigation. So you don't get bored. We don't get bored. The startup isn't stereotypical, but it is hard work. NextDrop has taken control of technology in a new way. Congratulations and thank you. Thank you.
Almost half of all startups are in technology. It's not an easy road, as a similar number quit within the first 3 years. You need an idea and perseverance, and meaningful support from the city and the region can ease the path to your goal.
Plzeň je jediné město v Evropě, kde hlídají bezpečnost čidla.
Rozeznají zvuk výstřelu anebo volání o pomoc a spustí poplach.
Mají klienty.
They have clients in Sao Paulo and Amsterdam, and they're from Pilsen. Jalud Embedded. They develop and manufacture devices for detecting dangerous sound events. What's the benefit here? Our device can reduce the time it takes to call the emergency services from about 7 minutes to less than 5 seconds. We can monitor a scream in the street, a car accident, someone drowning on a beach, a broken window. And how did you get into this unconventional field? From the very beginning, we wanted to create a product in the area of security, but that also would not violate people's privacy. It turned out that we managed to develop a product that is not only innovative, but can actually save lives.
Zájem o něj mají i v Londýně, v Brazílii, Panamě a Nigérii.
We've been building the product for years and we're still only a small company. On the other hand, as a smaller company, are you able to adapt better? Yes, and we're closer to our customers so we can react faster to their needs. Well, thanks, Lukasz. Lukasz definitely had a clear business vision. But sometimes business finds you, Vetlimce, and finally animals, because startups are not just about technology and technicians.
Our own animals were injured, and we wanted something better than the classic plastic cone.
And so we have the first textile pet cone.
It's been a long road. We tested them for several months in cooperation with veterinarians to make sure that they were comfortable, but most importantly, safe.
I can see it doesn't bother him. I guess he can eat and drink in peace.
Definitely. He's not restricted at all, and that's the most important thing. And it really contributes to good recovery in the dog. Our cone simply gives him maximum comfort. So, do you like this idea?
It's great. Congratulations, girls.
Thank you.
So these are startups in Pilsen, a great place for living and for doing business. Why? Meaningful support. It permeates all levels of the education system, from children in kindergarten up to budding entrepreneurs and established companies. Business is no joke. It takes an idea, an eye for the prize, and above all, not being afraid to try. Organizations like Sitport can provide you with a foundation, support, consultation, everything you need. Even though the hardest decisions will still be yours. Thank you, and see you at Sitport. Goodbye and good luck.
It was the second phase. Now is the third one. It means incubations. When the startups are here, we can help them in the third phases, which there is the main company's business innovation center. And for example, they have some activities that they can pay the startups, or they can help them with mentoring. And the fourth, the last one, it's for companies and startup which are really grow, which are very good ones, maybe big ones. And there are, again, mentoring, helping. They can expand the Business Innovation Center. They can help them a lot. So that's fine. That's something what we have in Pilsen. Thank you and have a nice day.
Okay, some question for this unique regional ecosystem.
Well, I like it, so I have to ask a question. Thank you very much for such inspiring work. I got a question, maybe you can answer or you cannot. Now, who are your staff? Are they all engineers or they are from pedagogic background? And how your system is financed? Because this is a really expensive adventure. How you finance yourself? And how do you select your staff? Are they engineer or social scientists?
City of Pilsen pay this ecosystem because they can see that it works. The people, they would like to stay here, they would like to do these activities, so it works and the city can pay. And about the engineering, it's we are not engineering. Someone, maybe, not all. It depends. It depends. Mostly it's young people and people who want to work with this community because it's not so easy. In Sitpor, for example, there are really guys, girls like Big Bang Theory. They don't know how to knock, they don't know how to say hello, but they are so clever. We have some guys from national team of hackers, etc. But you need to have like love to them, to want to work with them.
So the team is volunteers?
Yeah, can be. Some of them, yes, and some of them we are paid by City of Pilsen.
Thank you.
Okay, we must continue. Tomáš, please. Thank you very much. Next one, I would like to introduce my colleague from Germany and their very good experience regarding to cooperation between industry and maybe rural activities from city WUNsiede. Gerhard Meindl, stage is yours.
So, ladies and gentlemen, a warm welcome from my side. I want to talk about a certain very, very special experiment we took in WUNsiede for about 24 years now. So we started as an experiment, then we were quite successful, then we had to challenge industry and research to back us up on the growth of the idea. And now we have a very successful, let's say, energetic landscape, which is now acting as a best practice example and is visited very often from people from everywhere in the world. But the good thing is it was man-made. It was not coming from heaven or whatever. So there was somebody who had an idea, there was another one who had a problem, and there was a municipality with a problem. And then the things started to move. And today we end up with the WUNsiede way of energy. It's a vision of a zero-emission energy future becoming a reality. So the WUNsiede way is not moving. Okay. So why do we do this? Sorry, that's the only slide I could not interpret, but forgive me for that. I'll tell you afterwards why I couldn't do it. And it's obvious, you saw the small pair of hands that we donate the world back because it's only lended from them. It doesn't belong to the adults. So how do we do it? If you imagine, if you want to have a real business setup for energy supply in this real-time world, this requires loads of money. I should keep that next slide for the end, because that's the icing on the cake. But I don't want to put the tension bow too far. So we did it because we always formed public-private partnership companies for each new, let's say, technology or large asset we had to implement to maintain movement. As an example, we have formed several companies that support our energy generation system. That's the WUNbio. It's in the name. It's dealing with biomass. Then WUNelectro. It's the same. Solar Park, WUNsiede. Funny thing, or funny, let's say, aspect, when we wanted to form our first larger PV array in 2004, we approached the bank. It's the public bank, the municipality bank. It's the Sparkasse. Most of you know about that. And they told us, what are you going to do? What are you going to invest? A PV array on the roof of your storage building? Oh no, you won't have a credit from us for this. This is a crazy idea. So they left us standing in the rain, and we had to realize, oops, they do not realize, but we do not want to stop. So we created some sort of a fundraising initiative to invite our customers and citizens. And the very good outcome was they oversigned the money volume 3 times. So first of all, we had our budget to create the first solution. And second thing, we had an idea that they want to go further with us. So then it's WUN pellets. As you can see, they are dealing with the generation of wooden pellets. The WUN Connect, you will see afterwards, is heavily necessary because you can do whatever you like in generation of energy or dealing with biomass, but if you cannot monitor or steer it, you're lost in transition somewhere. And our latest baby is the WUN H2, our hydrogen, let's call it company, yes. It's a company which operates a big battery storage facility and a huge electrolyzer asset. And later on, I will tell you why it's so important that we have the battery and the electrolyzer in one entity. So for the time frame, just to give you an idea, we are talking about renewable energy sources. We are talking about storage, energy efficiency, IoT, and market models. We have a time setup starting in 2001 until today. And you will see that there have been several, let's say, technologies or angles of sectors that came not to our knowledge, but that became necessary for us to follow our strategy in the making. I do not want to talk about every and each of this. It's just to give you an overlook. Most of it you can simply understand from the name of it. And initially I wanted to tell you about a fairy tale, because once upon a time, this time was exactly in the year 2000, the municipality of WUNsiede and the Stadtwerk WUNsiede had to decide whether they want to keep their grid license for electricity or they want to give it away to the big, heavy partner Bayernwerk, who was very eager to catch our grid license as well as loads of our neighbors did before. But the municipality had lost so many jobs with industry that went away in the past, so they didn't want to lose the last 71 in the Stadtwerk, and they, let's say, did some sort of an assessment what they could achieve with the natural surrounding they are located in. And they found out they have loads of forest-based biomass to be used. They have a suitable, let's say, sun and PV surrounding, and they have certain volume of wind coming up. And then the mayor took the decision to give it a try. So he collected all his people from the council and they created a plan, and then they got started. As I told you, we wanted to have the first PV array in 2004. It was a larger scale PV array, but the bank refused to finance it. And then we came back with the idea of do the participation from the very beginning for our customers and the citizens, and it went very, very well. And for the time being now, we end up in a situation that we really have to think about market design, because all the activities have grown that much and fast. And we have collected a lot of partners that stay in WUNsiede, that have a common company with us. For instance, WUN-H2 would never have happened if Siemens wouldn't have become a shareholder in there. Because an electrolyzer unit, it's not that cheap and it's not that easy to be set up and operated. But as soon as they told us, look, we want to stay in there for the technology and we want to stay in there for the financing, let's go for it. So the rest is not history, but very soon or very fast to be told. Me personally, I joined the game in 2011, and I'm very proud of it because I could support all the activities from the scientific side. I am responsible for the coordination of all the R&D projects in SWW, and there was quite some reasonable amounts that we could use for, let's say, the surrounding we needed in terms of science to have a safe feeling to continue with all the technologies already installed here. So this is our masterpiece for the time being. It's our energy park. The most important thing is down here, the blue one. It's no animation any longer. That's the electrolyzer unit with 8.75 electricity megawatts intake. Sorry, too fast. And it will be doubled up very soon because all of the hydrogen we are producing is already sold out for the next 3 years. And now coming back to what I told you before, why is it so important to combine an electrolyzer unit with a battery storage system? Most of the people that are not that experienced and the pure electricity guys keep on telling us there's a prime type of energy, which is electricity. You can use it in any direction and you have to maintain that you can use it in any direction. So, okay, that's their opinion. The problem is, if you only follow the electricity way, and the grid people think if there is a surplus, we just switch on the electrolyzer, and if the surplus is gone, we just shut it off again. You can do so, yes, but your OPEX, your operational expenditure, will explode because technical systems mostly do not like the idea of being turned on and off very often, maybe several times a day. And if you have the buffer as a battery, you can just have a continuous operation. Your OPEX will be very low and you have the best outcome you can get. So now for the future, hydrogen is one of the backbones of our system for energy generation, storage, supply, and consumption. So we use it in many purposes, and we use it in all sectors wherever applicable. The grid, I mentioned it before. There was a certain grid strategy or regime, you can call it a regime anyways, because we had the big players and they were operating the grids top down. And still those big players are not at all amused that we have turned it around and now we operate our grid bottoms up. But I'm pretty sure they will realize that it's no use fighting the people, it's no use fighting the customers, because the customers have already realized that it's easy for them to become, let's say, a prosumer, so a producing customer, or maybe pro-stormer, a producing and storaging customer. We have decided to take them all along into a common business model. We want to do the business with those, and I will tell you in the end and show you in the end what we have prepared for them. Yeah. We also want to integrate all types of, let's say, rolling storage. Although there's still some negotiation to be done with the car manufacturers, they don't like the idea of their battery being misused as a rolling storage only, but they will realize that they can become a viable part of the electricity grid, but they will not be the prime. They have to obey to the grid, let's say, requirements. So now back to the migration of the consumer, maybe with a house, maybe with a flat. We want to offer a business model for each and every one of those where they can become our business partner. We will help them invest in their PV and storage setup, maybe in a hydrogen setup in their house if they like to do it that way. We will take care about generation, storage, and using scenario. And we want to migrate existing distribution system into future storage systems, especially our natural gas system. We have about 1,300 customers we supply with natural gas today. And in 2 years, we will not have them any longer, but we will migrate our distribution pipe system into a hydrogen storage and distribution system using the hydrogen that comes out of our second electrolyzer unit. And for this local business case, we are in close connection working with the industry, with the financial industry, with science and research, because we need to have a lot of new solutions in terms of financing, in terms of, let's say, monitoring and steering, so that every owner has a safe feeling that he's still the master of his house and the master of his assets. But in addition, he is a very valuable shareholder in our new common energy business case in WUNsiede. And I think, oh yeah, there's one more. The idea now is very interesting for other municipalities as well. So we had to form a new regional municipal company, which will now act as a fundraising, building, operating, and supplying company for the whole region of northeastern Franconia. Okay. And now I'm done. Your questions.
Thank you very much for such an interesting presentation. We've seen this morning the gentleman presented about green solutions. Now, we are pretty aware that everybody's moving towards e-equipment.
Yeah.
And you mentioned large storage of batteries. What are the solutions there for the recyclability of those batteries? They have lifetime. What solutions are there to recycle them? Because this is a tragedy that will come sooner or later. We are piling them. What solution do we have?
Yeah. So we have two approaches here. In WUNsiede, first of all, we recycle rolling batteries. We take them along. We do the analysis. What's the rest of capacity in it? We combine it for the, let's say, static use, and we implement them in our system. We build new storage system, not moving any longer, with no temperature differences coming up and no humidity changes. And this gives them a second period of life where we can use them. And after that, we're working together with the original equipment manufacturers with some research projects, what we can gain out of it. But we are not done yet, but we are on the way. Sorry about that. We are on the way.
Thank you.
Next contribution is from my colleague present here. Just a moment. Okay. Okay. Industry meet research, recap of new experience.
Exactly.
10 minutes, please.
Yeah, I'll try. Thank you, Milan. Thank you for the short introduction. I know the time is running. I would like to make a recap. Also, I would like to thank for the possibility to be here, also as a late substitute, or as Prince Harry would say, a spare one. So we are going to go through our experience with the collaboration of a research of an industry. And I'm coming actually from the industry, therefore a short introduction from my side, from my company. My name is Mitra Adamenko, and I'm for the last 2.5 years an executive assistant of a CTO at a company Vago in Germany, in Minden. And it's a pretty large company, an old one. We have been established in 1951. We have more than 25,000 catalog products. We are counting almost 10,000 people all over the world. We have a pretty good sales numbers. The previous year was a record one, with 1.35 almost billion euros. We have 9 production sites worldwide, and we have over than 80 locations and about 300 trainees and dual students which have the vocational training in our company. What do we actually do? We have 4 business units, or can be limited to the 4 business units. We have a strongest one that would be the interconnection of the electric parts of the maybe known Vago clamps. If anyone wants to take a look at our products, just tell me. I have a couple in the trunk. then interface electronics, automation business, and solutions for the data services for our clients. We are represented in almost every industry, starting with automotive. We are not in the cars, but in the sites themselves, in the plants. We are in railway, in power engineering. Building is our home, actually. We are strong represented in marine and offshore business. Also, elevators, excavators as our strong clients, and some others. Oh, sorry, that was the wrong one. So coming to our story, some of you may say, I know what you did last summer. And last summer, I was at DSMI standing next to this poster here in the same jacket, I think also. And we made the first initial run in the direction industry meets research. We said that we want to have a sustainable development of our company, and we want to build it up on 3 pillars. We want to have a technology leadership and secure it for us. We want to have a new personnel which is highly educated, and we want also to get people more acquainted with our products and with our company. We do that already in Germany, and the last thing we would like to do, what we want to go international. So, in the timeline of ourselves at DSMI, at the end of the last day, the pretty exhausted Vitali and happy me were sitting together and planning how can we do it. And we predefined the tasks from our side. We interviewed a couple of students who would like to involve in our research topics. We are pretty fast with collaboration agreements, so we started, or we had one already in September. Then, as a company as it is, you go in a budget planning, so you can have a certain amount of budget for these research activities. We defined the tasks, we applied it to the students, and we set up the project in the beginning of a year. So in January, we started the project. From WAGO's side, we supported them, but performed it was from the students of the Sumy State University. And in May of 24, last month, we have successfully finalized most of them. The one is still running, but there is also good progress in that. There is a short overview of the possible topics. I don't want to go deeper in this, of the topics we had for these 4 students, but I want to tell more about the working mode. We wanted the students to try something new. We don't want simply to give them the task, but we wanted for them to learn to be the project leaders. We wanted them to guide their team, to rule their team, to define the goals, and most important, to communicate with the team, to pick them up. In order to communicate, we had a team of experts from WAGO's side supporting them in their tasks, in their also taking a closer look at the results, going into the discussion, and we had a regular reporting for the WAGO experts. Also, we had the personal job fixes, we had a personal sparring partner for them, so they can optimize their solution and go directly to the goal of every project. Our results, we have great results in 3 projects already. The one is still ongoing, like I said, and actually every of these topics will get a further development. And for one of them, there are also some patents ongoing, which we have to thank for the students. Taking a look at the time. As a summary of our experience, did we have any challenges? Sure, we did. The first one would be the distance. In this case, we all acknowledged or already known to work within the distance, but here also the mask couldn't help because the guys couldn't go out of the Ukraine. Then we had a communication issue, not only from side of the university, but also from our side. It was also a part of the process for the employees of WAGO to overcome the German they use actually in everyday's work and to communicate it clearly to the project partners from Sumy State University. And we saw that they actually speak one language. The English itself was not a problem afterwards. And the third challenge is it was a leadership. It was a leadership issue for the students to take over, to lead the experienced guys at the company and to build up the project the way they want to do it and make the others work for them to achieve the requested goal. So actually, we mastered all of these challenges. And coming already to Outlook, what would we like to go? What would we like to do further? We would like to build up even closer cooperation with the research. Technology leadership becomes and remains our goal, but also the co-creation. Oops, it's confusing here. We would like to have a closer integration in education. We would like to share our experience, but also to learn from the youth, to learn from the young people having other point of view on the products we know for 20, 60 years, I don't know, and bringing something new into that. And we would like to also achieve a higher recognizability. We want to secure that the name of WAGO is a certain quality footprint, and to raise also social awareness for our activities to the community. So as a conclusion, we would like to thank Silva State University as a partner. We learned a lot along this process and would like to learn more. We want to continue and to expand further divisions, further topics. We only had mechanical engineers, and you others should try it. Thank you very much.
Thank you very much. Very, very short question.
8 minutes. I
Okay.
Myself.
Thank you very much.
Yep.
Last speaker of this section is a colleague from University of Hof in Germany. And last 10 minutes for you.
Thanks a lot. So, a very warm welcome from my side. My name is Simon Kolb. I'm today's spare for my boss at Hof University, Dr. Andi Gradl. And I'm here to present you our new project at the Institute of Hydrogen and Energy Technologies called HYBABO, which is an acronym for the hydrogen region, Bavaria and Bohemia. First of all, we are a so-called Interreg project, which is a funding project or a funding program of the European Union to fund programs which focus on inter or cross-border cooperations. In that program, we are in the priority 1, focusing on research and knowledge and technology transfer. And the aim is to develop and increase new technologies in cross-border regions. So, what are our stakeholders? To make it short, all the community, counties and municipalities of this region and the chambers of commerce and industry and the local action groups. Our project region is located in the northeast of Bavaria and the bordering region in the Czech Republic, the Karlsbad region. Inside this region, we have already 2 counties which are very advanced in hydrogen technologies, which is the county of WUNsiede, as we already heard, which which is the lightning star in North Bavaria, and the county of Neustadt-Waldnath, which also had a so-called high experts program of the Bavarian state, and they already have a concept for their county. But if you look at the map, we see there are lots of gray spots, and our goal is to close, to eliminate these gray spots and develop a concept for the cross-border region so everybody knows about hydrogen and what can be done and what can't be done. So what is our content and our aim? We started 2 months ago and have around about 2 years of time. And we will start with workshops and knowledge transfer to inform all of the necessary people in that region. Another aspect is we want to do a potential analysis of hydrogen demand and the capability of production inside this region, and inform all the people living in this region. Because in the last few months and years, the topic of energy and transition towards more environmental friendly technologies is kind of a more black and white discussion. And we try to smooth that hard discussion at the moment a bit out. Our target group are the small and middle-sized enterprises, research institutions, and also educational institutions. The main goal we have is to establish a group of round about 100 people which work together on a concept for the overall region on both sides of the border. Therefore, we made our timeline. We started 2 months ago. On next Friday, we have the first meeting with all our stakeholders to get in touch with them, because we need information from them. We need data and we need their opinion. And we need to get in the same boat to achieve our goals. In the next month, we will start with our potential analysis if we get all the data we need from them, and will develop our regional concept for the next 1.5 years. And in the end, if everything works fine, we'll have a hydrogen economy in this region. What will we do in our workshops? First of all, you all might know that it's always important to know the status of the plannings of your government and which fundings programs you got. It's very important for all the companies which participate in our program. Another big topic is we want to give them the fundamentals of hydrogen technologies. So everyone participating in the project has the same status of knowledge. And we want to develop some case studies, because we are not allowed to make specific concepts for one enterprise, but we can do more or less fitting case studies which might be adopted by them. We have 3 focus topics in our project. First of all, how can I use hydrogen senseful in industry? How can I use it in mobility? And how can I produce it? And what do we have to do to store our produced hydrogen? For the industry, we are focused on applications where I need direct heat through a burner. For the mobility, we will focus a bit on the truck use and the application in transportation and logistics. And for the production and storage, we do not want to only have a look on the classical way by electrolysis. We also want to present solutions how to produce hydrogen from biomass. For our potential analysis, we need to determine our H2 demand by each of the shown sectors. We need to collect data for the potential of generation from biomass and electrolysis in the region. And as I mentioned, we need to create case studies and sample projects for our companies which participate in this project. Another big point, as I mentioned, are the public relations. We want to spread knowledge. That's very important, because if the people don't know about the technologies, they tend to be a bit more reserved and say, if it works, I'm not sure. So information is very important for us. We want to go to public information events, not like here, more to the events where we get in direct contact with the companies. We want to make informations through our classic media, public, print, and online. And the goal is to provide well-funded information without any, it should be a neutral view. We are an institution, we don't want to sell anything. Therefore, a very neutral and well-funded information concept is important for us. And in the end, our concept should look like this. We want companies on both sides of the border to work together. Because if you go back in history, this region with only the except of 60 years of the Iron Fence always worked together in economic aspects. And therefore, we want to achieve that this happens regarding the hydrogen economy of the future. So, thank you for your attention. Are there any questions?
Thank you very much for this talk about hydrogen after burning produce water. Is that water safe? And considering all the toxic element that we have into the process of generating the hydrogen, how safe is that water?
In our region, water is not the big topic. We have enough of it. If you're focusing on that, or do you focus on the treatment of my processed water? What did the question aim to?
The question is about the byproducts of burning the hydrogen.
Okay, yeah, but that depends on the specific use case. If I burn it, I have to check, of course, are there any hazardous residues, but most of the time hydrogen, or in most applications, we tend to use fuel cells. And of course, if I burn hydrogen, nitrogen oxides are a critical point, but it's state of the art. It can be done. I don't think that it's not more hazardous than burning methane. Thank you very much. Thank you.
Thank you very much for this section, and now we have a common photo outside this building. After this photo, we go to the lunch. Thank you, and we can continue.
New materials, intelligent manufacturing systems, smart mobility, biomedicine and medical technology. These are the main fields in which we pursue research, development and innovation in the Pilsen region. Create your future with us. Innovate with us. Our region has a history of innovation. Important trade routes have always led through here. The first book was printed here. The first electric lamp was lit. We've seen dynamic developments in transport and new fields of medicine. Two of the world's leading brands, Škoda and Pilsner Urquell, were created here. We are successfully continuing this tradition. We are a region with traditionally strong industrial players, innovative companies, and major university institutions and successful research centres. But we're not just an industrial region. You can spend your free time wandering through the countryside or visiting historical and industrial monuments. You can be active or relax with great food and great beer. There's something for everyone. Here in the Pilsen region, we're involved in materials engineering. Research into metallic materials, 3D printed machine tools, special steels, the research and application of thermal spraying, and new technologies for the forming and heat treatment of metals for mechanical engineering and the automotive and energy industries. For example, if you ever come across a smart window which controls the amount of thermal solar radiation passing through depending on temperature thanks to a special coating, this patent originates from research at our university. Manufacturing, power plants and industry in the Czech Republic and abroad use intelligent control systems designed by engineers from innovative companies from the Pilsen region. The university's Research Technology Centre is developing completely new applications for contactless thermal imaging measurement, and not only for industry. Sophisticated computers that are built into medical devices are saving people's lives, and they're also being used in industry, transport and aviation. Smooth running. Let's take a look at another rapidly developing field, smart mobility. But we're not talking about just developing new electric drive systems. This is about a whole range of technological innovations for the operation and management of urban traffic, wireless charging, autonomous systems testing, and transmission development. One leading field we're dedicated to is biomedicine. This focuses on research and development in the fields of organ replacement and regeneration. This includes research into the prevention of viral infections after kidney transplantation, as well as research into antibiotic resistance. Specialist software is helping to diagnose and treat liver cancer as sensitively as possible. Software and diagnostics are also helping to prevent transport, medical, and sports injuries. Create your future with us. Utilize the potential of the Pilsen region. In practice, in research, at the university. There will always be innovation. Let's succeed together in the world. Innovate with us. The Pilsen region, the best place for innovation. New materials, intelligent manufacturing systems, smart mobility, biomedicine and medical technology. These are the main fields in which we pursue research, development and innovation in the Pilsen region. Create your future with us. Innovate with us. Our region has a history of innovation. Important trade routes have always led through here. The first book was printed here. The first electric lamp was lit. We've seen dynamic developments in transport and new fields of medicine. Two of the world's leading brands, Škoda and Pilsner Urquell, were created here. We are successfully continuing this tradition. We are a region with traditionally strong industrial players, innovative companies, and major university institutions and successful research centres. But we're not just an industrial region. You can spend your free time wandering through the countryside or visiting historical and industrial monuments. You can be active or relax with great food and great beer. There's something for everyone. Here in the Pilsen region, we're involved in materials engineering. Research into metallic materials, 3D printed machine tools, special steels, the research and application of thermal spraying, and new technologies for the forming and heat treatment of metals for mechanical engineering and the automotive and energy industries. For example, if you ever come across a smart window which controls the amount of thermal solar radiation passing through depending on temperature thanks to a special coating, this patent originates from research at our university. Manufacturing, power plants and industry in the Czech Republic and abroad use intelligent control systems designed by engineers from innovative companies from the Pilsen region. The university's Research Technology Centre is developing completely new applications for contactless thermal imaging measurement, and not only for industry. Sophisticated computers that are built into medical devices are saving people's lives, and they're also being used in industry, transport and aviation. Smooth running. Let's take a look at another rapidly developing field, smart mobility. But we're not talking about just developing new electric drive systems. This is about a whole range of technological innovations for the operation and management of urban traffic, wireless charging, autonomous systems testing, and transmission development. One leading field we're dedicated to is biomedicine. This focuses on research and development in the fields of organ replacement and regeneration. This includes research into the prevention of viral infections after kidney transplantation, as well as research into antibiotic resistance. Specialist software is helping to diagnose and treat liver cancer as sensitively as possible. Software and diagnostics are also helping to prevent transport, medical, and sports injuries. Create your future with us. Utilize the potential of the Pilsen region. In practice, in research, at the university. There will always be innovation. Let's succeed together in the world. Innovate with us. The Pilsen region, the best place for innovation. new materials, intelligent manufacturing systems, smart mobility, biomedicine and medical technology. These are the main fields in which we pursue research, development and innovation in the Pilsen region. Create your future with us. Innovate with us. Our region has a history of innovation. Important trade routes have always led through here. The first book was printed here. The first electric lamp was lit. We've seen dynamic developments in transport and new fields of medicine. Two of the world's leading brands, Škoda and Pilsner Urquell, were created here. We are successfully continuing this tradition. We are a region with traditionally strong industrial players, innovative companies, and major university institutions and successful research centres. But we're not just an industrial region. You can spend your free time wandering through the countryside or visiting historical and industrial monuments. You can be active or relax with great food and great beer. There's something for everyone. Here in the Pilsen region, we're involved in materials engineering. Research into metallic materials, 3D printed machine tools, special steels, the research and application of thermal spraying, and new technologies for the forming and heat treatment of metals for mechanical engineering and the automotive and energy industries. For example, if you ever come across a smart window which controls the amount of thermal solar radiation passing through depending on temperature thanks to a special coating, this patent originates from research at our university. Manufacturing, power plants and industry in the Czech Republic and abroad use intelligent control systems designed by engineers from innovative companies from the Pilsen region. The university's Research Technology Centre is developing completely new applications for contactless thermal imaging measurement, and not only for industry. Sophisticated computers that are built into medical devices are saving people's lives, and they're also being used in industry, transport and aviation. Smooth running. Let's take a look at another rapidly developing field, smart mobility. But we're not talking about just developing new electric drive systems. This is about a whole range of technological innovations for the operation and management of urban traffic, wireless charging, autonomous systems testing, and transmission development. One leading field we're dedicated to is biomedicine. This focuses on research and development in the fields of organ replacement and regeneration. This includes research into the prevention of viral infections after kidney transplantation, as well as research into antibiotic resistance. Specialist software is helping to diagnose and treat liver cancer as sensitively as possible. Software and diagnostics are also helping to prevent transport, medical, and sports injuries. Create your future with us. Utilize the potential of the Pilsen region. In practice, in research, at the university. There will always be innovation. Let's succeed together in the world. Innovate with us. The Pilsen region, the best place for innovation. New materials, intelligent manufacturing systems, smart mobility, biomedicine and medical technology. These are the main fields in which we pursue research, development and innovation in the Pilsen region. Create your future with us. Innovate with us. Our region has a history of innovation. Important trade routes have always led through here. The first book was printed here. The first electric lamp was lit. We've seen dynamic developments in transport and new fields of medicine. Two of the world's leading brands, Skoda and Pilsner Urquell, were created here. We are successfully continuing this tradition. We are a region with traditionally strong industrial players, innovative companies, and major university institutions and successful research centres. But we're not just an industrial region. You can spend your free time wandering through the countryside or visiting historical and industrial monuments. You can be active or relax with great food and great beer. There's something for everyone. Here in the Pilsen region, we're involved in materials engineering. Research into metallic materials, 3D printed machine tools, special steels, the research and application of thermal spraying, and new technologies for the forming and heat treatment of metals for mechanical engineering and the automotive and energy industries. For example, if you ever come across a smart window which controls the amount of thermal solar radiation passing through depending on temperature thanks to a special coating, this patent originates from research at our university. Manufacturing, power plants and industry in the Czech Republic and abroad use intelligent control systems designed by engineers from innovative companies from the Pilsen region. The university's Research Technology Center is developing completely new applications.
How are you doing? Okay, we got to be on time today because there's a lot of things planned for this afternoon. We have 4 speakers today. The first one is Erwin, who will be talking about cyber-physical production system design, decomposition for internal disruptive avoidance. You have 15 minutes, but once a stand-up, it means that you got less than 5 minutes.
I understand.
Okay? But I think we need to be shorter than that to save time for this session following. Okay, thank you. Take it, Bob.
Thank you for the kind introduction. So I try to be on the point and welcome you to this presentation. So it's a presentation about design of manufacturing systems in a period where we have different challenges. So we talked today also about IoT, digitalization, but a lot also about sustainability. If you are thinking at the European definition of Industry 5.0, for example, we have not only sustainability, efficiency, and so on, human centrism, but we have also the problem of resilience. So I brought one of our current works, so we are still in progress, but we will show you how we approach the topic about how to create design guidelines for more resilient manufacturing or production systems, and therefore for avoiding or for managing disruptive events. So going through the presentation, that's the agenda. So we will have first a bit of motivation, backgrounds, then the results itself, a validation that is taking place in our laboratory in Bolzano. So I am from the Free University of Bolzano. There at the, I already told to some people in the lunch, it's there at the border between Austria and Italy. And I will show you afterwards also how we implemented this in a demonstrator and what are then the future challenges for the next time. But going to the motivation, so what motivated us also to deal with this problem was that we are digitalizing since now around about 10 years in our laboratory, but also together with companies, the manufacturing systems, production systems. But what we have seen is that especially the small and medium-sized ones, they have difficulties with how to design this. So we are here in a very big company with Daikin, so I'm sure that here there will be lean teams, there will be industrial engineering teams that are dealing with that. But what about the smaller ones that don't have these facilities or these resources? So we need to provide them also some kind of support. Another issue is that we faced during the last years several of such kind of unplanned or disruptive events. There was the Corona crisis, there was the evergreen ship that was there stuck in the middle of the Suez Canal, how we know. I know there a company in Austria working on components for motorcycles. They, for example, they had also in this ship some containers, and they needed then to wait for other 3-4 weeks until there was coming then another shipload going in another route, and therefore they had a lot of problems also in disruption. They needed to reduce the speed of production or the capacity of production to only 20% of the normal thing. And that's, of course, a big issue for any company. So resilience has gained in importance. Then, if we are talking about resilience, and I think those of you that have done this also a research side, you know that we have different ways how to approach resilience. There are causes that are coming from external factors, and we have also some issues that are more internal factors for being more resilient or for facing such kind of challenges. So the good thing is that, maybe the bad thing is that we are quite uncovered with the external factors, but at the other side, regarding the internal ones, that's the part that we can deal, that we can manage, and therefore we tried also to put a certain focus also on that one, on this research. And you see here also a bit of insights in digital twin, digital shadowing. We are working a lot also with these technologies in our research group, in our laboratory, so we tried also to come from that side, how digitalization and digital twins can help us for making production systems more sustainable and more resilient. So going to the maybe more theoretical background also about resilience, you know, we can have resilience, or we can have disruptive events that are affecting a lot or having a huge impact on companies. And you see this also on this graphic, how maybe the productivity is going down, the capacity, the production is going down. And then as a company, you need then to recover. In the sense of recovering, you see also that the resilience is defined as the ability of the system to withstand these high impact disruptions, as well as also the capability to mitigate and absorb this kind of impact that is coming from such kind of disruptions. Usually we are talking then also about bounce forward, bounce backward. So bounce back means that you are quite fast in recovering, and you are quite fast also and robust in order to turn quite quickly to the status that you had before. At the other side, we want to bounce forward, which means that we are afterwards more agile, we are more adaptive, and we are adapting that much that fast our production system that afterwards we are coming out more stronger from such a crisis than we were before. In literature, there have been some works, especially I take out here the one of Chrysoloris from Greece, that worked on the measurement of resilience, and he used there the penalty of change, how you see it, this POC, which is basically multiplication or formula, an equation that is combined by the impact of a disruptive event and how often you have this kind of event. So the probability that is coming from disruptions. And we have based our work also on this penalty of change you will see afterwards. Then regarding the digital shadow, digital twin, I would like only to introduce the differentiation between these terms, so that we are talking also about the same thing. So we know that digital twin is the one when we have really a bidirectional information flow going from the physical model to our digital one, and afterwards we are elaborating the data in some way with data mining, data processing, with AI, with simulation, and we are going then back with some new information for adapting then maybe also in real time our production system. So that would be the real digital twin. And with the digital shadow, we are more on the monitoring side, so somewhere in between where we have a monodirectional information flow. So we see also that one helped us in our research. And as a methodology, we are, let's say, working a lot with MIT, with Purdue University, Worcester, so some American universities that use systems engineering for designing complex systems, like there could be an airplane or a space shuttle or other critical structures, but also manufacturing system is quite a complex system in general. So systems engineering is used more and more. I see also in Germany many more colleagues are using systems engineering also for that now in Europe. And we are using it since about 10 years, where we are usually asking ourselves also, what is the need of the user? Then afterwards, we try to define what is the requirement, the functional requirement for the technical system. So we need to translate it in a technical language. And we need to measure it in some way. So this is the FRM that you see there. So how this functional requirement can be measured. And there comes into play also then the penalty of change for measuring the resilience, how we will see afterwards. And you have physical solutions. So these are our design parameters, how we can design or solve in that way the problem, where we could have also multiple solutions, so alternative solutions. So this is the method where we were starting also for doing this design decomposition, like you see here now also this design decomposition tree. So you're starting usually from one big problem, a very complex problem, like let's imagine how to design a space shuttle. That's a huge problem. And my colleagues in the US, they told me also that in this methodology, they created such design decomposition trees that were hundreds of levels in order to face such kind of a big project. And we started here in our design decomposition from the question, from the customer need or user need, what we can do to avoid the negative effects of disruptions in our cyber-physical systems, how we can therefore, as a functional requirement, increase resiliency, and what will be the measurements. Here we have used then the penalty of change. And the DP0, like it's called, so the big solution would be a resilient manufacturing system. But now we all know that with this, we have not solved the problem. Therefore, we need to drill down then this problem in more subtasks, in more sub-problems. And this is then taking place in this tree where we can identify or indicate and also the first level relationship between one and the other one in order to see also how complex the relationship in the whole system is then also. So you see on level 1, there's already then the indication minimize the need of changes. So here we are talking about the avoidance of disruptions occurrence, so the probability of that it happens. And at the other side, we have more the impact that is done or given by a certain disruption, which can be measured with our POC in case also as euros of cost. So what is the cost of the impact of this disruption that we face? Going down, we are coming then to the differentiation between internal, external. So we can have an external view or a view on the external factors, and we can have a view on the internal factors. Today, I will show you only the results of the internal ones. On the external ones, we are still working there in a separate work project, research project. So you see also from this tree that is indicated there on the right side above, we are only looking at one branch that we have actually further developed. And seeing there our minimize the occurrence of the internal disruptions, we have further differentiated in the next level, in level 3, that we need to have more standardized manufacturing processes in order to have a higher quality, and therefore we have the, let's say, right thing on the right time and so on in our manufacturing process. Then we need to support the manufacturing with information that is coming mainly or hopefully from a digital twin. So there the solution would be a digital twin of daily manufacturing, and the other is communication infrastructure. So we need to have an infrastructure where the machines are communicating with each other, which is basically then our IoT infrastructure that we need to set up. Something that maybe, again, a Daikin here, big company, has already done for all the manufacturing processes. If we are looking to small and medium-sized companies, they are already or still struggling also with that point. Then you see, again, we can decompose our problems into sub-problems. And you see there also the digital twin has been decomposed, that we need a manufacturing controlling unit. We need then also a digital shadow. The digital shadow is the one that is helping us for monitoring the system. And with the control unit, we can then steer, we can control it. And we need to define strategies for comparing different scenarios. And basically, you see there also production planning system. We need then also to implement all of this, our strategy and the daily production plans then in a production planning system or strategy. Again, if we are going then down, so you can see also digital shadow, what does this mean and how we can further decompose this. So we need, first of all, a single source of truth. So we need to collect the right quality of data and the right data. And at the other side, we need to do this also possibly in a real-time way, so that we have always, every second or every time when we are looking at it, the right information. And below, we have tried then to figure out what are the really hard design guidelines, how we can implement this. So you see the ERP software, relational database, script for requirement managing, production orders, machine status tracking, quality assurance and control, material parts tracking, worker status tracking. All this is part of this whole system for making our production system more resilient. And the interesting thing is here also to see at these relations that we see there, so how these are related maybe to one functional requirement. And this gives us also an idea how, in which sequence it's better to implement those designed parameters. Therefore, in this case, it would be there from this side, so from the left to the, from the right to the left. I see I'm short in time. Therefore, let's go on with the validation demonstrator. So you see here which of these design parameters we tried then to implement in our laboratory case study. So digital shadow in sense of data structures, status tracking, infrastructure with the DPs, the design parameters that you see there, and the digital solutions that we selected. So working with Microsoft Business Central as ERP, working with Python, working on the machine status tracking by event logs, using MQTT for communication protocol, and visualizing everything then with Grafana, because we have seen that a lot of small, medium-sized companies are going also to this open source system. And you see here our transfer line. So it's a transfer line where we have shuttles that are autonomously going around, producing a product. We have different robotic stations that we can put there. We have also human working stations that we can activate or disactivate. And basically, we have tried to implement all that, what we have defined before as the design guidelines, in our laboratory use case. So you see there also the analytics part, the simulation part, design, decision supporting system, ERP, the database, the Python script for the inquiry management based on the MQTT protocols. And the next future steps that we are now working on is to finalize our decomposition, because you have seen it's not totally ready. So we are working actually there on cybersecurity, on that branch, how we can deal with that. And at the other side, we try then to implement all these design guidelines later in our demonstrator. And in the second stage, we would like to do this then also together with a local company for testing it then in a real environment. And with that, I'm closing my presentation and I'm eager to answer your questions.
Thank you, sir.
It's done.
Thank you. Right. Just one time, because we got to handle the time. Our next speaker. So our next speaker is Advancing Circular Economy, the Products of Circularity Index as tool for sustainable design. And the speaker is Foivos. Oh, that's you. Okay, you're welcome. Come. And again, we go only 15 minutes. When you see me standing, there's you have less than 5 minutes.
Okay.
Okay.
Hello again. I hope you enjoyed the lunch. So I will not introduce myself again. So I will present you now. It was interesting that in the previous presentation we saw also about design. We will talk again now about circular design and how we can quantify how circular product design is. And this is the main concept of this research work. So this is a collaborative work from 4 different institutions: the University of Oslo, the National Technical University of Athens, the University of North Florida, and my company in Switzerland. So very briefly, again, nothing works again. Why? Okay, so very briefly, this is the agenda and the structure of the presentation. So we will see some key factors of the state of the art and some introductory and motivational points. Then we will see what is would be the actual study purpose of the study, and the proposed methodology, and some discussions and some conclusions. So we have 2 types of economies. Let's say we have the linear economy, and we migrating, let's say, right now to the circular economy, which wants to reuse resources in order to minimize, let's say, the waste and minimize the environmental footprint. But still, there is a lot of work to be done in order to achieve true circular economy. And let me jump to the next slide, which is a bit more informative. So here you can see with blue the traditional product life cycle, which is starting with the design, manufacturing, usage, and then after the first use, it's the recycling. So when we recycle, we waste the remaining useful life that the product has at the state of recycling. So we have introduced, let's say, the 2 inner circles, which are the repurposing of the product and the reusing. And this enables higher levels of circularity in order to minimize the waste and exploit near 100% of the value that the product has. So this means that sustainable product design is very important, but the question is how we do it, how we integrate how do we evaluate how circular a product is. And this is the main scope of this research work. And then another point that will allow the measurement of the circularity while the product is in use, it's the digital product passport that I talked in my keynote speech. So having data from the different stages of a product, it's very important in order to quantify some KPIs. So let's go to the main scope of this study. And the main, let's say, research question is how circular a product is. And this will be, it's a preliminary, let's say, study in order to introduce a measurement, we call it a product circularity index, in order to quantify how circular a product is and to have a measurement during the design phase of a product in order to see and to create circular designs. So this is the basic, our basic idea, which we are working on the product design and prototyping phase when we are actually developing the product. And we, when we design, we have various alternatives of products, designs. So we want them also to evaluate them besides the performance and the satisfaction of the requirements. We want also to have another KPI for evaluating alternative design, which is how circular a product is. And this is the main cycle, let's say, of the methodology that we propose, is that we need to, when evaluating different alternative design, we select the most suitable and then we calculate the product circularity index, and then we do the same iteration until we reach the desired levels. So moving forward to the specific methodology that we created, we have created those 6 different categories, which has to do with product modularity and simplicity, the design philosophy, the materials, and specifically circular materials that are being used to the product, the manufacturing simplicity, the upscaling philosophy, which has to do with what happens after use, meaning how to disassemble, how to maintain, and then, okay, we have the maintenance. So these are the 6 categories where we have paid attention and we have analyzed. So in order to do that, we have created, we thought many different ways of how we can calculate this circularity index, but we couldn't think one generic method, that analytical method that could serve this. So we have used the questionnaires. We have created right now 30 questions under those categories that we saw before in order to evaluate how circular a product is. And this is, okay, this is the equation to calculate the product circularity index. It's just a sum of the weights that we give to each of the questions. So let's start with the design philosophy. So we see that if the first question and the most important one is whether the product is being designed to be reused or not, because we know that we have one single-use products and we have multiple-use products sometimes. So we need to design it with the notion that this could be reused in the future. And then is the product having modular components, and how modular? Those components are standardized or not? If there are clear interfaces between the different components, which will make the disassembly and the reusing or the maintenance even easier. And then if we go to the materials, if the materials that are being used, what are their properties? Do they harm the environment? Have you reused materials from other products without generating new materials? Are recycled materials are used? Or are renewable or bio-based materials are being used in order to extract the different aspects of circular design. And I think this is the biggest category, which is the manufacturing processes, so which has to do with in how many facilities this product is made, how many processes it has, if it has permanent or temporary joints, meaning you have welding or you have with bolts that can be easy disassembled, because we can imagine that a product that has welding, it's not very easy to be reused because you need to partially destroy it and fix it again. So if it has screws, you can unscrew it and you disassemble. Or how easy it is to make the parts, or are you reusing components as is, or you manufacture everything from the beginning? And the design for quality, this is a very important one. For example, if the product is easy to be inspected, for example, if you are using vision systems or laser scanners or anything but human, for example, if the surface of the product has a reflection or absorbs light, then you cannot automate the process, so you cannot scale it up, for example, very easily. If the components are easy to distinguish and to identify what is their current quality in order to see whether to be reused in the future or not, and so on. And now, if we go to the design for warranty, maintenance, or it's, I think it's very similar. So if there is a need, for example, for special tools for disassembling the product, or if there are any certifications and trainings that the operators need to be having in order to do the remanufacturing, or if there is a repair service, if they use new components or reused. And if the OEM repair services are accessible to customers depending on the geographic location. And the final category is design for the future, which is can the components from this product be easily integrated into manufacturing of the same product? Or, for example, has a life cycle assessment been conducted to evaluate the environmental impact of the product from the production to disposal? These are some key questions. Or if the product, for example, if the product have some complementary, have multiple lives or not. We see that there are some overlapping between the different questions because it's not very easy to distinguish, to classify them in one category. So moving to some discussions, because this was the very preliminary study for creating this index. So we are currently working with a use case in the automotive domain in order to see how we can calculate this circularity index for some of the components of the car. So we believe that this approach, it's a very lean. Of course, it's not 100% complete, needs to be extended, but at the same time, it's very practical in order to have an idea when designing whether what you do it's circular or not. So this work was partially supported by 2 European projects named Pluto and Circulus. And thank you for your attention, and I look forward for the questions.
Only because I'm working a lot with companies, and I was already thinking how I would apply it with a company. Are you sure that's more something for you maybe to think afterwards? Are you sure that you're using a yes and no? Because I'm thinking at some examples, and I'm always there somewhere in between. It may be a 1 to 5 or something could be possible. And then I see it as a really good instrument that can be used also as a basis then for developing afterwards a quantitative one for each single question, seeing how it's measurable. And that's much more work maybe in the future, also in the EU projects maybe, but very good starting base.
Yeah, thank you very much for the question. Yes, you are right that with yes or no questions, you cannot have all the detail, but on the other hand, we believe that having yes and no, it's more objective than having another scale that it's not analytically calculated, because it will be very difficult for a human person to quantify something that is very difficult to quantify. That's why we selected this approach with a yes and no in order to be objective. And we have seen that this is working at some extent. But yes, if we could quantify 100%, let's say, a value for each question, of course, it will be far more better. But at this point, it's very difficult to quantify all those questions because it's very difficult, or some of them nearly impossible to quantify them. That's why we selected this approach at this stage. In the future, as I said, we are working on an updated version of this in order to see how we can make it more detailed and to get to have higher level of resolution, let's say, because this is your point, that we are missing resolution. Yeah.
That was not half question. That was a full one.
Okay.
Any
Thank
more
you.
questions, but we haven't got time.
Yes, of course, I have a question. Can we go to the screen with the methodology when you have yes, no?
Sorry?
Can you go in the back to the screen when you have yes, no methodology, something like that?
Sir, this is your
My name is Jan Górecki.
for your colleagues and everything.
Okay.
Oh,
Thank you.
Oh, you have
can I ask? I have a question. One simple question or advice. Maybe this will be advice when we stop and when we have some question about the fixing connection.
Which slide you said?
You have some question about if we can separate the part of the unit of the device. Yes, I don't see if we stay on the yes or no, because I think that your suggestion was very, very good. If we stay only on the yes and no, we must remember that during when we try to separate part, for example, when we have a screw, we have some washer, and sometimes we need to exchange some parts. When we separate the unit of machine, we need to exchange. We don't have this question if we need some new part, because when you, do you understand my?
Yeah, I understand, but this goes to if you have standardized components, because the washer, it's a standardized and does not affect,
Yeah,
let's say.
but when I have not locking washer, for me this is not standard washer.
Okay.
But in some company, of course, it could be a standard washer, but not locking usually is not standard. Okay?
Okay.
So for me, you should add a question if we need some additional part or something like that.
Thank you very much.
You can consider that after the break. So our next speaker is the next. You, okay. Our next speaker is Said, talking about simulation-driven evaluation reward system in activity-based manufacturing environment. Okay, that is for you. You can take your time. Make sure that you have 10 minutes. The order is for the question.
Thank you. So, hello guys. I'm Yunais, and I'm finally a PhD student at Free University of Bolzano. And today's my topic is about little away from the overall topics, but actually it's very relevant because of the industry 4.0 and smart manufacturing. So yeah, this is not working. Yeah, I don't know. It's not. Yeah, in the big. Okay, so okay, let's. Okay. Okay. All right, it's back. Okay, I'm pressing the back button. I'm sorry. Yeah. Okay, I'm here. So, so the problem which I'm trying to work on is basically there was previously this kind of fixed role-driven shop floor where there's a team leader and there are a bunch of workers and they all have a role to do. You know, they are responsible for certain mission groups, you know, and they work for those mission group, whatever task is allocated to them, they will work towards that and complete them. So now the industry is shifting to activity-driven shop floor management, where the tasks are like allocated in a smartwatch, where workers are given a list of tasks based on a skill, and they could select and go to the specific mission group to solve it according to what they like to do in the list of tasks. And in this kind of a system, there are a lot of challenges. The good part is that this offers a lot of flexibility, because in a role-driven case, you know, it is like, okay, they are only responsible for that mission group. But in this case, anybody who has the skill can walk around. If the skill, if the demand for the other group is there, then they can work with them. Now, the major challenges in this case is that, you know, there are a lot of tasks, so they are like, you know, getting confused which task is ideal to choose. And also there are chances that if you're given a lot of choice, you know, they can also delay in favor of easy ones because of procrastination, because it's just a part of human psychology. And then, so we have to have some systems to give the ideal tasks to them so that they select them and so that they can plan for ensure efficient task completion. Now, what is the objective? So the objective is to design some reward systems
to be conveyed to the workers so that they can maximize that reward. If you maximize those reward, then ideally you are doing the optimal path for doing the task. So the task which we have completed as a part of this is to help workers to select optimal tasks in a dynamic environment, because the environment is changing, the demand is changing, and to reduce unacceptance. So unacceptance is a key indicator here. That's how we identify the problem from the shop floor, because we measure how many tasks in the shop floor gone unaccepted, not accepted by the workers, to be completed on time. And this was an issue which we are trying to solve. So here I try to propose two reward system. One is based on the worker skill, and other is based on the historic skill utilization and unacceptance. So what is the methodology? So I have just tried to obtain a certain configuration of workers. For example, worker one has skill 1 and skill 3. So worker 1 is missing skill 2. So all the workers are not having all the skills. It's like specific workers will have specific skill, and also all the workers are not belonging to all the mission group. So if you see these lines are not connected for certain worker. For example, worker 1 doesn't belong to mission group 3. So this is the arrangement of the shop floor. So what we try to do is we try to extract the data from this, which are like the skill metrics, so which will represent which worker has what skill. Worker distribution is a metrics which talks about whether this worker belongs to this mission group or not. And open task is like which is from the which is the task which is currently available to work on. And total open task is just the sum of all the tasks in the open task metrics. Progress time is how much time the worker takes to complete that task. Worker availability is whether that worker is available at the moment, because they might be engaged in some other task. And we have this unacceptance metrics where they are how many tasks are gone unaccepted and how many tasks are accepted. So then we calculate this to a reward system. First reward system is pretty simple. It is based on the skill. We assume that, okay, the highest skill, the highest demanding skill will get highest reward. But in the second case, it is different. So since the environment is dynamic, the second reward changes every 1 hour. And it is calculated based on the skill demand and also on the unacceptance. That means if some workers or somebody is not accepting a specific task for a long duration, then that task will be rewarded more, as this reward system is connected more to the unacceptance of the task. So moving forward, we created this simulation where workers are put in 2 reward systems and observed for 8 hours. And there are certain problems. For example, this is a complex process, but one of the problems is maybe a task conflict can occur where the same worker with same skill, workers with same skills and belonging to the same mission group, but they got the same task. So who will choose the task? So in real world, this cannot occur because the most motivated worker will pick up the task. But actually, in simulation, we cannot measure this motivation because all the workers are same. We didn't model them psychologically. So then we are just randomly picking them and giving them. But actually, in the real world, we have extracted the data of motivation through like which task they are accepting more through their data, and we know it. And moving forward to the results, as you can see that, I think, sorry for the bad quality. Actually, if you see the reward one is actually almost straight. That means the whatever task is coming up, they are getting accepted at the same rate. But in the unacceptance case, you can see there is a lesser amount of open task, and also the unacceptance ratio is going down in every hourly basis. So there is a change. So the most interesting metrics is this. So these 3 workers with these 3 skills, in reward system 1, they try to maximize all the skill 3 because skill 3 is basically rewarding more. So they accept all the skill 3 and maximize it because they are trying to maximize. They are just rational agents. But here in this case, the worker 3 have accepted 38 tasks of skill 1 because of the unacceptance, giving him more reward to reward skill 1 because it was not accepted for a long time. So this is the effect which you have seen in the previous graph that, it had lesser amount of unacceptance due to the higher acceptance of the lower task. And again, we have run this simulation for 10 days to see how does this came after the reviews, because also as provided by the reviewer that, okay, can you run it for a longer duration for 10 days, whether this is consistent throughout the unacceptance ratio. And we found that the reward 2 is always reducing the unacceptance, which is pretty good. And the conclusion is that we conducted this simulation on reward system, and we found that this is consistent across different days. We did a paired t-test for statistical validation of the our reward system and found that the reward system 2 is better. And the future work is to conduct on the real case or in the shop floor, we implement the reward system in the real case, and to see whether the reward system is truly working for in the real world. So thank you for listening to me, and if you have any question, you can ask.
So we have time for a couple of questions. Question? Then I'll ask. Now, you say skills, skill 1, skill 2. Is that task 1 or task 2?
Okay, yeah, that's a good question. So basically,
skills, one operator can have multiple skills, but maybe in this case, I'm not sure whether it's task or skills.
Yeah. So in this case, actually, the skill and the task is same, because if you have the skill, the task is same. But the difference is that if the task belongs to another mission group, like for example, it comes from mission 1, which is not belonging to your mission worker distribution, you cannot take that. So that's why you can see those zeros there. Sometimes, they cannot take that task, the worker. So that is different. Yeah. Thank you.
I thought it was really task rather than the... Okay, thank you very much.
Thank you.
And here is your certificates for your publication and your attendance.
Thank you.
Thank you very much. Who's the next one? Yeah, running ahead, we're going to wait.
The last one. I hope not least. So my talk is exactly before the coffee break. Yeah. So it means we can utilize whole the coffee break. Yeah, for Q&A session, etc. No?
Oh, if you do that, you have trouble. I ask a lot of questions.
Yeah, sure.
Right. So our next speaker is Bogdan, and we'll be talking about generative AI in agile projects and delivery management. Okay. The floor is yours. Okay. Is it working? Okay. Let's go ahead.
It works. Okay.
You don't have all the time. You have only 10.
Yeah. 10 already. Yeah, it was 15 at the beginning. Okay. So good afternoon. It's up to you. Mr. Speaker, it's up to you. I'm fully in your hands. Yeah. So good afternoon, colleagues. Yeah. It's really nice to see all of you at the conference. So my topic is that, as you can see, generative AI in agile project delivery management. And here I am representing actually two affiliations. My full-time employment, Accenture Baltics, it's an IT consultancy company. And at the same time, I am the associate professor in Riga Technical University. Yeah, so agile ways of working, this is what I'm doing daily basis, involved fully in delivery management. And actually now I want to present you some of the steps what we now are doing, how to make our work more efficiency. So let's move on. So for last 5 years, I've been working in agile environment, and actually one of the framework what we're implementing is the Scaled Agile framework. As you can see, the Scaled Agile, this is lean enterprise, is the world's leading framework for business agility. So what is our goal? Our goal is to build agility in the company. It doesn't matter which the company. It might be finance, manufacturing, whatever, yeah? And some of the values, key pillars, what we based on, it's Scrum or Kanban ways of work, and it's built in quality, implementing DevOps development and operations with cloud solutions, team backlogs, solutioning, etc. And here you can see the feedback loop, what we're implementing between the user story feature mapping to run our ways of working, run program increment, and every 10, 12 weeks to have these cycle loops, and Scrum or Kanban ways of working. So what's our proposal? So now, actually, before ChatGPT was launched, yeah, I believe everyone aware of the ChatGPT functionalities, yeah. So all the decision been made by a lot of workshops, design thinking sessions, yeah, and fully based on the expertise of the key company stakeholders, yeah. But now the time has changed, yeah, and the business operates more and more faster and requires more and more efficiency way, yeah. And I have just presented here the full PI cycle, which we've been implementing, and at the same time, there are a lot of decisions at the same time should be done, yeah. And here we have recognized that obviously ChatGPT and all, yeah, ChatGPT just one of the implementation, yeah, but in general, machine learning tools can support us to make these decisions much more faster and efficiency, yeah. And I have prepared some case study for presenting to you. And actually, so let's be concrete. So what's our research goal we've got? Yeah, to implement Gen AI tool, in our case, it's ChatGPT, into agile ways of working for project and delivery management. So what was our tasks? To ensure that enterprise implement the agile ways of working, implement tools in ways of working with the delivery management, measure the agile team's efficiency, yeah, measuring, extremely important, because to implement this is one way, but how to ensure that we are progressing, we've done it efficiency, we have to measure that. I have one result for that. And enhance delivery with scaled agile framework are implementing Gen AI tools, yeah. So what's the next? As you can see here, I'm showing you the delivery model what we're implementing, yeah. So based on the lot of epic level, feature level, user story level, it's a backlog items, refinement sessions. So we've got a backlog, yeah, and through the mandatory Scrum ways of working, sprint planning, daily stand-ups, backlog refinement, daily stand-ups, presenting the working increment, piece of value, what we've been delivered, collecting feedback from the stakeholder, coming back to the retrospective. So for all of these steps, Gen AI tool can support us to make this our deliverables more successful and efficiency, yeah, in each of this way. So, and now I'm actually ready to present the proof of concept, what we've got. So as you can see, of course, it depends on the lot of specific what we have in the company on the client. Yeah. For example, here I'm showing you the detailed view how we do decomposition of the deliverables what we've got, yeah. So majority of you are aware, yeah, that from the company level, the highest level, we have a roadmap, yeah. I didn't show that, yeah. I just the roadmap level, strategic changes what company want to deliver. So we are decomposing based on our objectives and business values. We are decomposing this to some small pieces which we are going to deliver. Yeah, we call that feature or functionalities. Yeah, and here exactly I'm proposing this approach. So we are decomposing our features to user stories, to small deliverables, small pieces of value which we can deliver during the iteration. To keep small iterations extremely important, as we can have quite fast cycle loop, And it helps us to collect feedback and adopt our deliverables more frequently, more fast, collect feedback from the stakeholders, etc. And this is extremely important as after the user story level, we are creating a backlog with all the deliverables, what we need to proceed with in upcoming sprint or iteration, And this is the exactly GenAI tools can support with that. As you can see here, I have provided some fragments of the code, what we've done actually to make it happen, So I'm not gonna to go into details, but this is just an example of the implementation of the solution. So here, as you can see, go deeper, not just feature or user story level. We also, our ways of working based on the Kanban board. Probably majority of you are aware with the Kanban. Kanban also it's quite useful tool in manufacturing, how to track the items in the board. And for example, as based on our Kanban board setup, we have different columns, different steps, processes in during our deliverables. So backlog, to do, implementing, on hold, POs acceptance, done, etc. So, and we have exit criteria for all of these steps. And this is exactly one of the way when GenAI tool can support us to identify and proceed with the exit criteria between all of these phases. So having that, we can build more efficient ways of working, how to proceed between the columns within our deliverables. And actually also I have put some fragments of code here, actually, and Python script, which is delivered in JSON file and transfer it to a YAML file, because it depends on the cloud, it's Azure DevOps solutions, etc. So YAML pipelines, this is the format how we are delivering pipelines in Azure DevOps environment, So, and what's the results? So as a result, based on what I showed, we've got refined backlog with the user story level. This is, I have put some examples of our user stories which we've been generated based on that, So we have classified that, for example, user story related to data collection, to data analysis, user interface, alerting, whatever. It depends on the ways of working, the last, what I want to share here, the metrics. Yes, you remember, one of our goal was to collect metrics. And following the metrics, we can ensure that we are progressing, because every sprint, based on our deliverables, each sprint, we have to collect the metrics, how team is progressing. This is not the purpose of this presentation to go deeper in this metrics. Some of them I presented last year. But there are metrics, as you can see here. I'm happy to cover that more detail during the coffee break, But we are tracking each of the iterations separately. So this is each of the iteration we are tracking separately to ensure that we're collecting relevant data based on the user story we completed, we delivered, and we can proceed with the tracking efficiency of our team. And because there is a phrase that you can't manage if you don't measure, So, and this is exactly what we are doing on a daily basis. And as a conclusions, so based on this presentation, we try to demonstrate the ability of GenAI models to assist in project delivery, agile ways of working and management, on the different levels, different scales, because scaled agile framework requires scaled teams, lot of teams, diverse teams, etc. We can combine GenAI performance with human expertise, because always the SMEs, subject matter experts, point of contacts can validate the results, can proceed with the updated data, etc. And there are a lot of opportunities to implement many different language models to make this work more efficiency. As I promised, it was very fast. I managed in time. Yeah, thank you so much. Let's keep in touch. Here I've shared my LinkedIn. Yeah, please feel free to keep in touch. And postscriptum, my department in October organizing conference in Riga, Latvia, October 3rd, 4th. If you're interested in, please, we would love to host you in Riga these days. Yeah, so thank you so much. Thanks.
Any question? We saved a lot of time, and he's happy to take questions. No question, we're not going for tea.
But you promised at least one.
Okay, I got a question.
Yes, please.
You refer a lot to ChatGPT, but I have a challenge with ChatGPT because when you put some key engineering questions to ChatGPT, hopefully you get it wrong. How do you handle this issue in your situation?
Yeah, very good question.
If you put a question, you need to train it to understand what
Yes,
you want.
exactly.
If you are not acquainted to it, it can be the opposite of the sound.
Yeah, exactly. So the proof of concept consists of the ChatGPT because it's very easy. Yeah, we don't need to spend, we don't have even capacity to create our own models, yeah, etc. So what did we do? So we just, what we tried in our POC, we just, okay, I can't, okay, unfortunately I can't now again, yeah. Someone loves this conference, probably they locked the screen. So the proof of concept, it was visible in some of the slides that we just created a boundary for our research in terms of the analyzing the business context. And business context consists of the market demand, consists of the external stakeholders, companies. So majority of this information are in public environment. Yeah. So for this case, we could use ChatGPT to ensure that our model works. Yeah. But obviously to go deeper and more specific stuff, obviously, but it's not about the existing data and information. It's about the data protection stuff. Yeah, how to ensure that model are not gonna to share commercial data, sensitive data, GDPR stuff. There are a lot of questions needed to be covered. Yeah, but it would be the next steps of our research. Yeah, so definitely we are aware with that. Yeah.
One good question over there.
I have to contradict to your opinion, Professor, because we try to do that with the company. We try to feed ChatGPT, Gemini, and Copilot with an existing instruction for a vacuum cleaner for a robot. And we simply upload it in there and ask, could you please derive us the requirement, the market requirements for this product? And you got a whole list. Then if you try in multiple clients, could you please systemize them according to IEEE group requirements rules, whatever, or in closer rules? They become an ID number, they become rationality, and so on and so forth. After that, we ask him, could you please take a look at the market? What is there already? For example, if you write the requirement, the cleaner should drive around certain objects on a floor. After looking closer at the market, he derived the measurements for these objects. For all the objects below 20 millimeters, they have to be sucked in. Otherwise, it should be, you have to take a look if there is an interference or collision, and so on and so forth. So it was like 5 minutes,
yeah,
but it was literally great.
Yeah, but this is exactly the goal of that they can train by themselves. Yeah, so.
Yeah, sure.
In terms of engineering, because in some aspects of
every engineering starts with requirements, therefore.
Yeah,
sure. In some aspect, really, ChatGPT can mess you. He goes around, he make a mistake, you go around, he comes back to the same place, he turns around. So for generic question, as you just said, where he got a lot of information in the public domain, yes, he can target. But there's some specific question he's not really well trained, especially GPT-3. Yeah, good enough.
We tried 4, but okay.
Well, thank you all. Thank you again. I think this is our last speaker. Nice, just good for you and for your collaborators. Yeah. Thank you. Zamknęło bardzo.
Czy? Nie działa? Dobra, działa. Wiesz co? A gdzie jest ten, żeby świeciło? A, dobra. Okej. Dobra. Aha.
My name is Justyna Trojanowska. I represent Poznań University of Technology in Poland, especially Faculty of Mechanical Engineering. Time for paparazzi. Thank you. After our session, we have a bus transfer, and I receive information that at least 3:45, we have to leave this building. So I need to change a little bit schedule for our session. We have three presentations. I know that you are ready for 15 minutes, but I'm sorry you have only 5. And question and answer session will be at the end if we have the time. So let's start. The first speaker will be my friend Monika Kulisz from Lublin University of Technology with presentation about integration of statistical analysis and machine learning techniques.
Ladies and gentlemen, my topic today is integration of statistical analysis of machine learning techniques for exchange quality control in candle or cartridge manufacturing. And because of short time, so maybe I will start with what was the aim of our research and task research. So we want to develop a decision support instrument to oversee the manufacturing process in a company producing all cartridges for candle production. And we have like three parts of our task. So first, the deep analysis of production process using the data provided from the company, then identification of the most important parameters that have influence to the candle inserts quality, and the last element was to use this important parameter to prepare the model that predicts the quality of the product using machine learning methods. So how we did it? First, you can see here the chart about manufacturing process, and we analyze each process, and then we define and identify the variables which has influence on the quality product. Then you can see here all variables which we define and identify, and as an output for our modeling was two types of product. Okay, so it means that we have good quality product, and not okay, so it means that we have a product with some mistakes. So at the beginning, we start with using chi-square test. So after
after this analysis, you can see that we have only 5 variables which has influence to the quality of the product. So x1, x2, x3, 4, and 7. And this kind of parameters we use as an input for our modeling. As an output, we have classifiers, so 1 and 0 option. 1, it means that we have OK product, and 0, it means that we have non-OK product. And we use 4 types of machine learning methods: super vector machines, regression trees, nearest neighbors, and neural network. And here you can see the methodology of each of methods. What is important for SVM, we use different Kellner function. For regression tree, we use limited number of splits to 20. For KNN, we use different distance metrics and also different distance weighting. And the number of neighbors was 10. And for neural network, we use training algorithm scaled conjugate gradient and softmax as an activation function. And we use only simple network, so means that we have like only single hidden layer, but we change the number of neurons in hidden layer from 10 to 100. And we divided data, as you can see here, 70, 15, 15, training, testing, and validation data. So time for results. Here you can see comparison about these 4 methods. Here you can see only the best model for each method. And as you can see, the accuracy is very similar from 84 and 5 till 86 and 0.9. So after accuracy, we can see that this 2 is the best. But we have another quality indicator which we can use to compare these models. And here you can see confusion matrix. And when we compare true negative and true positive options, we can see that the best options we have for these 2 models, and we got the same results. So which one we should choose? To choose between these 2 models, we can use area under the curve. And here we have, for these 2 models, the results. And as you can see, the AUC for ANN model is 0.735. So it's higher than for KNN model. So it means if it's closer to 1, it's the better quality model. That's why we more analyzing deep ANN model. So here you can see confusion metrics for artificial neural network model, but but in training data set, validation data set, and test data set. And as you can see here, it's for all data. And what is important, when we have test data, we have very high this accuracy because it's more than 90%. For training is 86 and half, and for validation is 85 and 6. And it's good if when we have better quality than for training, because it means that when we use the new data, like test data, we got good results, and this data were not used before. So it means that when we use it for the new data, our result should be okay. So now it's time for conclusion. We want to prepare some models, support the decision model to improve the quality of product, and it was all cartridges. And we, at the beginning, start with statistical analysis using chi-square test. Then we, using this chi-square test analysis, we indicate the most important factor, which were x1, x2, third, fourth, and seventh. And this kind of parameters we use to modeling to prepare model to predict the product quality, and we use machine learning method, which you can see here, like support vector machine, regression tree, KN, and neural network. And comparing all these methods, we got the best results for neural networks, and we can use this model, for example, as a decision tool, which can help managers to have improvement actions in their companies. And this is everything for today from me. I hope I made my time.
Thank you very much. Thank you for a very interesting presentation. As I said, the question will be later if we will have time. Now I invite my dear Ukrainian friend from Gdańsk University of Technology, Evgeny Medvedev, with the presentation about risk assessment.
Good afternoon, ladies and gentlemen. I'm glad to welcome you. Today I will give a report on the topic risk assessment at unsignalized intersection based on the human road environment vehicle system applying fuzzy logic. Our team introduced in this slide. Okay. Establishing the accident level in advance could be the initial step to assessing road safety. Thus, it becomes possible to implement appropriate technical measures to improve traffic safety. It is significant to unsignalized intersection or complex traffic junctions. However, current accident assessment method primarily consider traffic management factors, traffic flow parameters, vehicle conditions, and driver ergonomics. A more advanced system of estimates parameters is used less often. Only factors that can be quantified using technical means of traffic monitoring or the behavior and psychology state of the driver are considered. The study proposed a fuzzy inference model that consider classical and fuzzy variables based on the human road environment vehicle systems, HREVS. The research objectives are to design a fuzzy model that assess the risk level of accident at unsignalized intersection based on HREFS elements. Main research task, the research aim is to design a model accounting for uncertain factor, weather condition and pedestrian wear color that directly impact the accident rate. For this, a mathematical toolkit of fuzzy logic is used. Research task the first task is section of one of factor from each subsystem characterizing the human road environment vehicle system, which has the highest impact level on the accident. Risk occurrence at unsignalized intersection. Second questions, fuzzy model designed for accident risk assessment at an unsignalized intersection based on the mathematical formalization of fuzzy inference according to the Mamdani algorithm. And third, its approach development to accident risk assessment at unsignalized intersection based on fuzzy modeling results considering the HREFS elements. In the study, we understand risk. In the study, we understand the risk definition as follows. Risk is uncertainty about and severity of the consequence of dangerous situation of accidents at the road and network system due to HREVS. Concerning safety at unsignalized intersections. Therefore, the accident risk on unsignalized intersection, RA, due to Hrev's factors, is written in mathematical forms in this slide. The most sensitive, most important factors are selected from each HREVS subsystem due to previous studies that justify the significance of their impacts on the response function, risk assessment of accident at unsignalized intersection. First group factors, its impact pedestrian wear color on the risk of accident. Second, its impact intersection equipment on the risk of accident. Third, it is impact of weather conditions on the risk of accident. And fifth, impact vehicle speed of the risk of accident. The modeling framework demonstrated on this slide, the Mamdani algorithm is used as a fuzzy inference model. For the generating the results, display independence of the output parameter, target function RA on the input model indicators PWC, VS, VC, and IE. In this case, the mathematical formulation of fuzzy inference for a fuzzy model is presented as this form. Figure modeling results for risk accidents at unsignalized intersection by fuzzy model shows that 3 levels emergency risk have been obtained. Analysis of the results indicates that the number of hazardous situation, green, in 26 out of 81 possible. In this case, the response function is maximum RA is maximum, and the estimate value of the accident risk from the fuzzy model is greater than 47.5. This study aimed to develop a fuzzy model for determining the emergency risk on unsignalized road section, considering human road, environment, vehicle system factors. The fuzzy model was implemented in the MATLAB modeling environment, and its structure was assembled using the Simulink toolbox. The 81 fuzzy inference rule, due to the Mamdani algorithm, was modeled to cover the entire set of possible cases. Thank you so much.
Thank you very much. And the last but not the least, my dear friend from Kharkiv, Władysław Szlarmenko, with presentation about green logistics system.
Dear guests and the conference participants, first we thank the organizers and management of the conference who provide the opportunity to take part in this incredible event. Research results are presented to your attention according to the next theme, green logistics system, cargo bikes as an alternative to trucks. This research was conducted in cooperation of German and Poland universities by Natalia Shemenko, Krzysztof Kupfer, Władysław Shemenko, and Piotr Trianowski. My name is Władysław Shemenko, and I will present key aspects of our research, including the problem statement, the scenario of cargo delivery in a dynamic urban environment, the developed genetic algorithms, the developed unsupervised reinforcement learning, the obtained simulation results, identification of key stakeholders, and finally, the conclusions of our study. To start with, logistics costs are an extremely significant cost category due to the relatively high share of the revenue, and transportation costs are the most significant component of logistic costs. Recently, especially during the COVID-19 pandemic, e-commerce has been rapidly developing. Trade networks demonstrate dynamic growth in online orders. Online customers include bakeries, pastry shops, cafes, restaurants, hotels, and the general population. Orders are placed daily. The distribution system of the city is characterized by a dynamic environment shaped by the following factors, such as number of customers, customers' locations, customers' demand, warehouses supply, availability of products in warehouses, quantity of vehicles and drivers, and initial location of vehicles. The features of a dynamic environment is characterized by the features of a dynamic environment are stochastic variables, and we need to take into account various features of a dynamic environment and the given constraints to minimize the daily delivery cost, time, and CO2 emissions of cargo delivery by small consignments. So the goal of our research is to develop a simulation model to optimize the process of transporting small consignments within the city in a dynamic environment. How we can find the optimal route? For 5 customers, it's easier. However, for 25 customers, it takes 2 years to find an optimal route. And what about the routes generation for hundreds of customers? It will take millions or even billions of years. Based on the literature sources, we chose the Google OR tools, genetic algorithm, and reinforcement learning methods. The genetic algorithm is simply generalized for given options of vehicle routing problem, such as the number of available vehicles, garages, the capacity per load restrictions of available vehicle fleet, the maximum time duration of route and distance constraints, etc. The fitness function demonstrated on the slide was employed in the genetic algorithm to assess the quality of individuals, and it takes into account the total length of all roads and penalties for violating soft and hard constraints, such as time duration of a road and road length limit. The grid search was used to identify optimal hyperparameter settings for the genetic algorithm. Recent papers that focused on the application of reinforcement learning were analyzed. Almost all works focused on the simplest definition of vehicle routing problem and cannot not take into account soft and hard constraints. In addition, the reinforcement learning agents were trained on the randomly generated data and not tested on real data and not take into account actual distances between locations. In reinforcement learning, an agent interacts with its environment to learn optimal strategies by making decisions and receiving feedback in form as rewards. The actor-critic model architecture was chosen for reinforcement learning model due to its effectiveness in balancing between exploration and exploitation. So the associated vehicle routing problem was the reinforcement learning model was developed, which is able to solve capacitated vehicle routing problem for arbitrary number of customers, a single vehicle, and utilizing actual distances between locations. The actor and critic model architectures were developed, which are presented on the slide. They are based on the encoder-decoder architecture. The slide shows the encoder and decoder model architectures, which are based on the transformer architecture. The advantage actor-critic algorithm was developed for training the developed reinforcement learning model. So the Google OR tools, the reinforcement learning and the developed genetic algorithm were tested for the same 100 vehicle routing problems with 35 customers each. we can notice that reinforcement learning outperforms the heuristic methods while the genetic algorithm outperforms the reinforcement learning. However, the genetic algorithm works significantly longer to produce the results, while the Google tools and reinforcement learning generate results fast, approximately in comparable time. The trade network Lido is widely distributed in European Union and was chosen for modeling purposes with focus on Karlsruhe city in Germany due to its extensive bicycle road network throughout the city. 50 potential customers located in Karlsruhe were selected to conduct the research. Different fuel consumption trucks with different payload capacities were selected. In addition, electric cargo bicycles with different payload capacities were selected as an alternative to trucks. The distance matrix between 50 customers and 6 Lidl supermarkets was obtained using the Google Maps distance matrix API for cargo delivery by trucks. In addition, the distance matrix for cargo delivery by bicycles was obtained using the Google Maps distance matrix API. The differences between distance matrix for trucks and bicycles presented on the slide. The red cells indicate the distances that trucks need to drive more than bicycles. We can notice that majority of the cells are red. The differences between distance matrix for trucks and bicycles arise from differences in path alignment, one-way traffic on certain road sections, lack of cycling infrastructure in some areas, and challenges for trucks access closed zones like pedestrian areas. So in our research, we considered several cargo delivery scenarios. One of the scenario is delivery by pendulum roads, where vehicles can deliver products from the assigned loading point. The performance metrics for the generated pendulum roads for the randomly generated supply and demand for different types of cargo bicycles and trucks are presented on the slide. We can notice that almost in every aspect delivery by cargo bicycles is more optimal than utilizing trucks, except total delivery time. Also, we considered delivery assembled roads, where vehicles can deliver products from different supermarkets. Such roads require fewer number of vehicles compared to the pendulum roads. Next, we considered the delivery roads, where vehicles can deliver products to many small customers. The performance metrics are presented on the slide. We can notice that cargo bicycles are a great alternative to trucks, and it enables a significant decrease in greenhouse gas emissions. Also, we considered delivery assembled roads, where vehicles can deliver products to many small customers from different supermarkets. Also, we can see that cargo bicycles is more optimal than trucks. So, depending on the priorities of the performance metrics and given constraints, we can select appropriate cargo delivery scenario that best corresponds to our conditions. The web application with a convenient UI interface was developed for modeling purposes and roads generation. The study simulated delivery routes for many small city customers with various vehicle types, such as trucks and cargo bicycles, utilizing different proposed algorithms, such as a genetic algorithm and reinforcement learning. Reinforcement learning and genetic algorithm outperform heuristic methods in solving vehicle routing problem. The proposed unsupervised reinforcement learning method outperforms heuristic methods by about 25% with comparable result generation time. On average, the developed genetic algorithm can outperform reinforcement learning by about 25%, requiring significantly more time, approximately 250 times longer to produce results. The simulation model allows us to make decisions depending on the priority of the criteria and constraints conditions. An appropriate scenario for cargo distribution in the city can be selected that best corresponds to these conditions. Utilizing electric cargo bicycles enables a significant decrease in greenhouse gas emissions, typically by a factor of 15 to 20, and even decrease of total driving distance and cost. The utilization of cargo bicycles has significant potential for sustainable and efficient green urban logistics. Thank you so much for your attention.
Thank you very much. Thank you very much, Władysław. Thank you for your time discipline. You have just 2 minutes for a quick toilet and we will meet outside and start our social activities. Thank you very much. Have a nice evening.